AI agents combine the best of what modern LLMs can do with what software has done for a long time, which of course is running functions that you design. Now, I'm going to show you how to build and deploy an AI agent, but before we do, we need to understand the underlying fundamental technology to make that happen. Now, the actual web application we're going to deploy with is FastAPI, one of the most popular Python web frameworks out there, because what you can do is really fast, of course, it's minimal. We don't actually have to write that much code to make it work. And then it's also very easy to deploy if you're using the right deployment option, which of course is Docker. We're going to be using Docker so much in this one. So really this course is a very heavy Docker usage course. So if you've never used Docker before, this is going to show you every little thing that you need to know and understand before you can go to the more advanced things like FastAPI, and then even beyond that, like LangChain and LangGraph. Now, we're using Docker because it can be done pretty much anywhere. In other words, if Docker can run, your application can run. That's true on your local machine, whether if you're using a Mac like I am, or if you're using a Windows like many others use, or if you're using Linux, any of those Docker can run on, and it's a really easy and effective way to make all this happen. Now, we're going to be using Python, and I'm going to show you how to use Python even just to serve up a standard plain old HTML page itself. All of that driven through Docker and Docker containers. We can spin up databases. We can also spin up open source AI models. So Docker Hub now has open source AI models if you weren't aware of this. And so this will allow us to use things like Gemma 3 and actually run various tools, which of course is what modern AI agents are all about, is running various tools. And you can do this with all open source. Granted, we're going to also deploy this application, and the only reason we can, or at least the easiest way we can, is thanks to Docker and Docker containers. So deploying it becomes far easier. We're going to use Railway, we're going to use DigitalOcean to deploy it. We're going to do a lot of fun stuff in this one to really build out your AI agent. Now, the agent part of it all is towards the end, because that is, well, after we establish all of these fundamentals. So for those of you who don't know Docker yet, this is a really important course for you so you can understand how to use Docker in your development environment as well as when you go into production. So I did partner up with Docker on this course, so thanks so much to Docker for helping bring this one to life. I'm really excited to show you. Let's take a look at the demo and also a little bit about the software we're going to be using in this course right now. Let's go ahead and do a quick demo of the result of the code, and then we'll look at all of the different components that build up this project. Now, of course, if you do a curl command on your machine, you'll be able to write a message that's vague, like research why it's good to go outside and email me the results. Now, all of that is going to work, and it's going to work thanks to all of the tools we're going to end up building. Now, the latency here is a little high in the sense that it does take a little time for the research to actually be executed and then for an email to be sent to your inbox. So I'm going to show you how to do all of these things. Now, where we start first, though, is by using specifically Docker and Docker Compose. Now, the reason for this is it helps prepare us for production, but it also gives us a really powerful local development environment so we can spin up any of the tooling that we might need at any time without touching the rest of our system. It really helps isolate these things on a whole new level. So once we understand how to use Docker itself, we will then start to build out a very basic static HTML web page so you can understand Docker and how this all works. Then we're going to go ahead and start building a much more robust web page using a lot of the same sort of stuff, and that is by using these requirements right here in Python. So we're going to have FastAPI in here. We're going to build out a FastAPI application. We'll do some basic integrations with a SQL model so you have a Postgres database so you can actually store data. Then we're going to elevate it a lot by using LangChain and LangGraph to build out our AI agent. And do so by actually integrating it into a FastAPI application so that you have an endpoint that you can do a couple of things with. Number one, you can store the data into a SQL database. Number two, you can use a supervisor agent and actually get data back into your user or do that emailing like I mentioned before. So a supervisor agent itself is a type of tool that you will build out with LangGraph. So first off, we build out specific agents that do very specific things. In this case, this agent will send an email for me. We do a research one that will do some research, and then a supervisor that can kind of combine all of it. Now, this is all powered through LLMs, large language models. And the cool thing is we can use the non-open source versions like the ones from OpenAI, or we can use what Docker has, which of course is inside of Docker Hub. If you go to dockerhub.com or hub.docker.com and search for all of the AI agents, I'll show you how to implement these as well. These are all open source and really useful for local development. Some of them can call tools, as in some of them can be agents, some of them cannot be. It's really dependent on the tool itself. But the idea of using AI agents is growing so much that we're going to start seeing a lot more open source tools that will allow for us to do these really powerful things. And so I really want to show you how to do all of this. Now, there's a lot to happen for this one. So if you're really just interested in the AI agent stuff, look towards the end. If you want to understand Docker at a fundamental level and build on top of it, then to deploy a Docker-based application, then you're going to want to start from the very beginning. Docker is a very powerful tool, and it's something that I highly recommend using, not just for building out your applications, but also for leveraging local open source AI models. Let's jump in. By the end of this course, we are going to have a deployed AI agent on the internet so we can use it as we see fit anywhere in the world through something called Docker containers. Now, as you might imagine, deploying code to the internet can get tricky. There's a lot of room for errors to happen. Docker containers help us minimize those errors because of the tool itself. It bundles up the application so that if a container can run, the application can run, the code can run, regardless of the programming language available. So for example, if you want to build your AI agent in Python, you totally can. That's what we're going to be doing. But in the future, if you wanted to modify it to something like Node.js, you'd be able to do that as well and still use the same deployment process or pipeline to get your code into production. The only difference here would be the running programming language that you're using, but Docker itself will be able to switch between the two as you see fit. Now, it also makes a really standardized way to bundle up your code in the process that you would be doing during development anyways. So for example, if I'm like, hey, we're going to build a Python application on your local machine, the first step there would be, let's download and install Python. The second step would be, let's download and install the third-party package that is in Python that allows for us to use that third-party package, otherwise known as a pip install of that package. Now, the same is true if we decided to go to Node and use Node.js. The first step would be, let's install Node.js. The second step would be, let's install the third-party package that we want to use to be able to use that third-party package, right? All of that is still going to be the same with a Docker container, except it will be very explicit as to what's happening. Step 1, install this. Step 2, install these other things. Step 3, run this. Docker containers bundle all of this stuff up in a way that makes it seamless. And it's why it's one of the most popular developer tools in the world, because it works incredibly well, both in local development as well as in production, regardless of what system you're working on, which in my case, I'm on a Mac, but I've done this on Linux and Windows many, many times. Now, the other aspect of this is all of the packages that already exist for Docker, all of the other container images that already exist. Now, I'm going to explain all of this stuff little by little as we go forward, but the idea here is you go on Docker Hub and you do a search for like Postgres, the popular database engine. There it is right there. You could just download it and run it with just Docker. You don't need to download Postgres. You don't need to download anything with the database itself to make it work. You just need Docker itself. The same thing is true if you do a search for Python. Python is also in there. If you search for Node.js, Node.js is also in there. If you search for Ruby on Rails or Ruby, Ruby's already in there. If you search for Nginx, Nginx is already in there. There's so many other pre-built container images that are out there that you won't need to do a whole lot of customizing just to get those things working. Now, in our case, we're building an AI agent out of Python and LangGraph, so we will customize it to our own use case. So really the thing that we're not customizing though is the Python of it all, and also the container itself. So we need to actually install Docker on our local machine to get this going. The first part of this course is really going to be all focused in how can we get Docker working on a local machine. Then we'll start building out our code more and more once we better understand how to use Docker and things like Docker Desktop, Docker Compose, and various other tools that you might want with your Docker application. Let's get started by installing Docker onto our local machine. And what I mean by that is really installing Docker Desktop. This is the one you're going to want to use locally because it gives you a nice user interface that allows you to manage all of the things related to Docker without necessarily learning all of the Docker command line commands. So go into the Docker Desktop, go to download Docker Desktop, and then download it for your system. Now, in my case, I have an M4 Mac, which means that I'm going to be downloading Apple Silicon, which I could check by going into About This Mac, and I can see the chip is Apple. So I'm just going to go ahead and download that version right there. Now, if you're on Windows, there's a good chance that you'll use AMD 64, but you might have ARM as well. Just check your system profile for those things. And then, of course, if you're on Linux, then you can also download this as well. Now, if you're using something like a Raspberry Pi or a virtual machine, I recommend using the installation script at git.docker.com, which will show you step-by-step as to what you need to do to install the Docker command line tool, as well as Docker Engine. Docker Desktop has the Docker command line tool and Docker Engine already. You don't need to install it extra. It just comes with everything you'll need on your local machine, which is when you go into production, you will need to have at least Docker Engine on there to be able to run your containers. Now, there's some caveats to that, of course, but generally speaking, that's what you'll want to do when it comes to installing these things. Now, the nice thing for us, when we go to deploy it, we won't install it on the actual production server. We will use servers that already have Docker installed that can just run our application. One of the huge benefits of using containers is that a lot of services are out there that can just run your containers for you. Okay, so once you actually have it downloaded, you're going to want to open up your downloads folder. Obviously, I have 2 in there. Open that thing up, whatever you just downloaded, and then you're going to go ahead and bring in that installation process. Now, in my case, I actually already have Docker on my machine, so I'm not going to overwrite my old one. So I'll just go ahead and say stop here. In your case, if you don't have Docker installed, of course, it's going to install it. It might take a moment. If you're on Windows, it might take a little bit of a different installation path, but you're just going to go ahead and do all of the defaults in there, and in which case you will then be able to open up your Docker Desktop container dashboard, right? So that's this right here. Now, if you're on a Mac like mine, it will probably go into your menu bar up here, which is off the screen right now, and you would just select the dashboard there, like go to dashboard, and you'll see something like this. So one of the things you'll notice is I'm open to Docker Hub, which is also on the internet. I typically go directly to Docker Hub on like Chrome or my web browser, but of course you can do it in Docker Desktop as well, and they're the same thing. They will do all the same searches and all that. One big difference in my case is that I'm actually logged in to Docker, to my actual Docker account, which you can always sign up for right now. Everything we've done so far is free, and it's really easy to get going. So if you have questions on that, please let me know. But the idea here, of course, is we need containers and images. This is the thing we want to start unpacking and start using very soon. But before we jump into that, I just want to verify that I have access to Docker in the command line. So I'm going to open up Terminal. If you're on Windows, you'll probably use PowerShell. You also might use WSL or Windows Subsystem for Linux. And of course, if you're on Linux itself, directly Linux, you'll use the terminal application like Mac. But the idea here is we want to be able to do Docker -- version, and we'll see something like that. We also want to be able to do Docker Compose -- version just like that, and we would be able to see all of those things. Maybe -- version doesn't work right there. Maybe it's something different, but the idea is Docker Compose is not an error like something like that, right? Unknown command, Docker Compose gibberish, right? So make sure you have both of those things installed. The actual Docker version actually doesn't really matter that much, just that you have it installed. Older versions of Docker will still run so many of these containers because the underlying technology for it has been fundamental since Docker came out. So we're going to be building off of this in just a moment, but the idea here is you just want to make sure that you can run various Docker commands like Docker PS, Docker image, all sorts of things like that. I want to show you why Docker is so powerful. If you go to hub.docker.com and do a search for, let's say, Python to start out, you select the very first result, or really any of the results, but let's select the first one because it's managed by the Docker team directly along with the Python Foundation. But the idea here is we've got Python. If I click on tags, I'm just going to go to the very first one. It actually doesn't matter which tag you're looking at here. You're going to want to just go ahead and go over to where it says Docker poll and then Python : that tag name. So grabbing this whole thing here, let's go over to terminal and just paste it in. It should look something like that, right? And so what I want to do is I want to run this version of Python right inside of the terminal. The way we do that is by using the docker run command, then -it, which means interactive terminal, kind of like a SSH session, as you'll see in a moment. Then you run that tag, you hit enter. What this shows you is it's unable to find Python locally, and then it goes through the downloading process. Now, if you're on a Mac, it might warn you, hey, do you want to allow for this to happen? Just go ahead and say yes. If you're on Windows, if it warns you, go ahead and say yes. But the idea here is now I've got Python 3.923 right there. It's all installed, and I can print out something like, hello and world, just like that. One of the things I can't do is print out hello world like this without the parentheses. Now, I sort of assume that you understand this in terms of Python, but if you don't, it's okay. Let's go ahead and exit out of this now. I exited out. The way back in, again, is this right here. Really, docker run -it, and then whatever version of Python. So what I want to do is I want to just use my intuition and do docker run -it Python : and I'm going to go ahead and do 2.7 and then -slim -bulls I. I actually don't know if this will work or not, but I'm going to use my intuition based off of this other tag. Python 2.7 is a super old version of Python. In this case, it says it can't find it. Okay, so in this case then, I'll go back into Docker Hub and I'll filter the tags for Python 2.7 and see if there's anything in here. Looks like 2.7 might not be available, but if I do a quick search for 2.7, let's say point, and let's see if there's anything. There's one, 2.7.18 stretch. Okay, so now I'll go ahead and do docker run -it Python 2.7.18 stretch. Go ahead and hit enter. Once again, it can't find that. While that's downloading Python 2.7, I'll go ahead and just do a quick search for that in terms of the age. It was released in 2020. So it's 5 years old, but it's, I think, the last release of Python 2.7. Python 3 is the modern version of Python. So it's a really old version of Python, and it's only going to get older, and it's not one I recommend you using pretty much any time. But the thing here is Docker itself has the ability to use that old version. This just happens to be a really big image itself, which is why it's taking a little bit longer. But the idea here is I can pick and choose any version of code I might want to run and use. In this case, this is a 5-year-old programming language that will not be updated most likely in the future. And so it's really old. But what if I went to 2.5 and did a search for that? I don't see 2.5, maybe 2.6. Yeah, so it doesn't even have those older ones, but we probably could find it somewhere on the internet. I'm not really going to go through that process. The point here is really to understand that, yes, you can download these old versions of Python. There's 2.7 here, and I'm going to go ahead and try this out. I'll go ahead and print out hello world again without the parentheses. So this is showing the differences between the two versions of Python. Now, if I were to exit out of this again and try to go into Python 2.7 on my Mac and hit enter, it's going to say command not found. Python 3.9, I think, is installed on my Mac, in which case I probably would be able to go into it. It's not installed either. So neither version of Python is on my machine, but if I wanted to use it, I can use it with Docker just like that. And this is true with any programming language. So if you actually came in here and did something like Node, and with no tag, no colon in there, and just did Node, and just did that, it will grab the latest version of Node, as in the latest release that's available to your system. It will go ahead and run, download, and install that. And the actual version itself, if we do a quick search for it, we could see in Docker Hub what version of code this would end up being by doing the search for like latest in here. That will give us that version right here, which then shows us the latest version. And there's probably notes somewhere on Node onto exactly what the latest version is. in there as well. If you go into the overview, it's probably in here somewhere. There's a lot of stuff to it, so not really going to go through that. You could always grab the version inside of the interactive terminal as well, which is showing us the version right there, right? And so in this case, I can actually run all of my different node stuff. So console log and hello world. And there we go. So we've got our hello world. Okay. So now we've got a bunch of different ways on how we can just enter into other programming languages just with docker run-it and then whatever the image name is or the hub repo name and then the tag name. So when I say hub repo name, that's this right here. Right here, node, this is an actual hub repo itself. And while there's official images like Node and Python, you can also publish your own images like I do right here. So if I go to dockerhub/u/coding for entrepreneurs, here's a bunch of images that I've just deployed on here. There's a lot of them over the years that I've just pushed out and I can actually use. Something like CFE Nginx, here's one that you can actually go through. And I even have a usage command in here that we can use right now to see what it looks like. So I'm going to go ahead and ignore this -d here, and I'm going to go ahead and run it in my command line. So docker run, and then using -p. Don't worry, I'll explain all of these things as we go forward, but I just want you to copy what I'm doing here. And so what we've got is docker run at this port, and so on and so forth. So I'm going to go ahead and hit enter. Once again, it can't find that one, so it's going to go ahead and pull it. And so the next step, after it's ready, I can actually open up localhost to 8381, in which case we get this homepage, this web page just working. That is an actual Nginx page. It's actually built in as a container. So the point here is not to necessarily use pre-built ones only, but rather to build on top of pre-built ones and build out your own applications. Let's now start the process of building out our own container image. So I'm going to be using the text editor cursor for this with all of the AI stuff off. Feel free to add in the AI stuff as you see fit. I'm going to go step by step on how this ends up working. So first and foremost, I'm going to open up a project here into a folder that I created called dev. And in this folder, we're going to go ahead and say something like deploy AI agent. And then I'll go ahead and open this one up. Okay. So in here, what I'm going to do is I'm going to collapse the chat because I won't use that. But inside of this deploy AI agent, I'm going to go ahead and create a Dockerfile with no extension. So as soon as you do this, a lot of text editors might say, hey, do you want Docker completion, right? So if you're on VS Code, Cursor, Windsurf, a lot of them might say, hey, do you want the Docker extension, which I highly recommend installing. It's really good, easy to use, and it's something that I find useful from time to time. It does a lot of things with syntax highlighting that makes things easier, but you don't need it. So what is a Dockerfile? This is really just designing or really saying what are the conditions for our Docker container. If you remember back to when we just ran into Docker Hub, if you do a search for Python again, so if we did that quick Python search and you find Python here, what you could do is you can use this container image. So we've got Docker pull Python. I can use Python or Python latest. So inside of the Dockerfile, I declare what image to use, right? And so that's what we want to start with, just like we did when we ran it. And all you do here is say from, and then the image you want to use. So Python, and then the tag you want to use. In this case, we'll do latest. And so once again, the command is from, the image name, and latest. Now, if you are having, or if you have a username of some kinds, it would be something like from coding for entrepreneurs / the image name, CFE Nginx, and then colon latest. Something like that. So these two are equivalent in there in terms of how this ends up working. So once again, if we go to hub.docker.com/u, coding for entrepreneurs, there's my user. I grab one of them like CFE Nginx. We can see the command in here. And that's that whole thing. So it's actually this like that. So with the dash, and then once again, you can use latest in there, assuming that it's one of the tags, in which case it is. It says latest. Not all of them have the tag of latest, just so you're aware. Just go into the tags tab and you'll find it. Okay, so there's our Dockerfile. That's it. So how do we actually use this? Well, let's go ahead and actually come into our terminal now. I'm inside of the terminal inside of Cursor which just gives me access to go directly into this location where the actual Docker file is. Now what I can do is called build and run. So if I do Docker build, and then after that, Docker run, I'll be able to run my built image. Now there's a way to shortcut this, which we'll see in the near future. But the idea here is we do Docker build, then we can declare our Docker file with the -f, and then we can give it a tag name with -t, which I'm going to go ahead and just say my PyApp, and then I'll do a period as use the local folder, like look in the local folder for that Docker file, the local folder as context. We hit enter, this will start building out our application. So if you ever see these warnings here, just make sure that you're okay with the security. In this case, I am. I'm okay with cursor running these Docker commands, in which case it's now going to go ahead and start building out this Docker file. So the important part is this command right here. So once again, I'll go ahead and put in a little note for this. Then after it's all done, what I want to do is once again, use Docker run. This time I don't need to call, let's say Python. I'm going to go ahead and use PyApp, as in the tag I just gave it. Once again, I want to use an interactive terminal with -it so that it actually brings me into that version of Python. After a short while, the image is actually created, and in which case I can now go ahead and run docker run -it PyApp, and in which case it gives me the latest version of Python, right? It's very simply the latest version of Python. By the time you're watching this, it could be in the future, and you could be looking at Python 3.1 or 1315 or something way later, right? It could also be the exact version that we have. This is where deciding which thing you're going to inherit from is really important early on, so that it doesn't change on you out of nowhere. In which case, that's when you go into tags, and then you do a quick search for, let's say, 3.13. Once you do that, you can see here's that version that I'm going to use. I'm going to go ahead and change this latest to that version now. We're going to save it, which means that we need to do two things: build and then run. Build and run. So you're going to always need to rebuild these container images. Once again, I'm going to show you how to shortcut this soon with Docker Compose. But after we do that, we now have 3.13, and the actual container itself might be a bit smaller because of this slim bullseye. We'll talk about that more later. Let's go ahead and push our own container image to Docker Hub so that anyone in the world can use it. Now, of course, this means you log into Docker Hub directly on the internet, also in Docker Desktop, also on the actual Docker command. So if you go and do Docker login, you will actually see this. Now, if you logged into Docker Desktop, there's a good chance that you're already logged in on the command line as well. But in my case, I want to make sure that I am logged in. Now, I just actually built out a container image with this command right here. This will be the way I build it every single time. So now what I could do is try to do Docker push and then PyApp. Hit enter, and what it's trying to do is push PyApp. But the thing is, I don't have authorization to have an official Docker container application. I just simply don't. My Coding for Entrepreneurs app doesn't. Maybe at some point it will, so I need to change it a little bit. I need to make my own container image. So the way we need to think about this is our username on Docker Hub or through Docker in general, then our image name, then the tag we want to give it. And we need to build it with that tag and then push it with that tag. So in other words, I'm going to go ahead and copy this right here, and we'll go ahead and paste it, and we're going to go ahead and now grab my other one where it has my actual Docker Hub name, and then I'm going to go ahead and grab a new value, which is going to be simply, let's call this my AI PyApp test, and then I'll go ahead and tag it with latest. So now I'm going to go ahead and grab this, we'll paste it in here. It's now tagging it with that container image. Now, you could tag it with the same exact image, but the next step won't necessarily work, which of course is Docker push, and then we actually want to push that entire thing. So we'll push that whole image with the tag as well. So we'll go ahead and just do Docker push, and then we can go ahead and hit enter, and now it's actually going to push it into Docker Hub so that anybody can use it. Now, this doesn't mean that anybody would use it necessarily, but it will push it for us. And so we'll see that very, very soon on our profile, or you could always go into your account and take a look at your hub as well. So if you go into my hub here, you will eventually see what you're pushing into Docker Hub, which in my case is not quite there yet, but it will be really soon. And so the default when you push this, I believe, is going to default to being a public image so that anybody would be able to see it on your profile. So if we open this up, we can come in here and we should be able to see it very, very soon. Looks like it was pushed. So I'm going to go ahead and do a quick filter for that right there. Hit enter, and there it is. So this is a public image right now, but this is quite literally it, which is pretty great. So you out there in the world somewhere would be able to run this right now if you wanted to, and you'll notice that there's only one tag. So we could always change the number of tags. If you want to increment the tags, you just change these two commands. So you would change this to like V1, and then you could go ahead and build it again. And the build path should be a lot faster. Oops, I need that period at the very end. So let's try that again with that V1. And then I'll go ahead and pass in the push of that V1 again. And then I push that. And this also should be really fast. Notice these layer exists. So what Docker does is it caches things. It makes it really effective and efficient to build and push things. That's why you're seeing cache going really fast on the build this time, and then really fast on the push this time too. So we'll speed up actually doing deployments as well when it comes to using containers too. But now if I go into Docker Hub, I can list out here and I see V1 and latest. So if I were to go into my own hub and into that actual project, so let's go ahead and refresh in here. What we see is less than a minute ago. I pushed this one in here. I will be able to see all of the different things that I might want to have, right? I've got some health errors in here. We probably want to fix a bunch of things in here. It gives you a lot of feedback in terms of Scout, gives you feedback on how vulnerable of an image this is, and if there are security issues with it, you can always activate that as well. I can also go into my settings here, and I can turn this thing into a private repo, which I think is a good idea if you don't want your code or your repository to be open sourced, as in anyone can get it. So building a container image itself doesn't like protect your code at all, because you'll eventually put your code on there and then anyone will be able to run it like we've already seen with the docker run command, in which case you could just do docker run -it, and then you grab that container image in there, and then you could do something like bin/bash, which will give you a command line, a Linux command line, almost like SSH in here, which I could still run Python and get that original Python as well. But this actually gives me a whole sort of operating system itself within that Docker container. So it's actually really neat on how all of that works. Now, we'll go over that a little bit more as we build out our Dockerfile, but the idea here is we now know how to build and push these images. Now, the next step in terms of deployment would be to then have this image referenced in some sort of deployment process where we would download this image and then run it for us. But of course, we need an actual function that could run. This right here does not run. It just runs Python. It's not an actual web application at all. It's not a running application other than opening up Python for us, which is really not that complex. So of course, we want to build on top of it. Python has a built-in web server. Let's take a look at it now from the context of Docker. So the command to run the Python web server is python-m http.server, and then the port we might want it to be on. So let's say port 8000. So in order for the Docker container image to run this, we bring in what's called a command element here, in which case we would break this apart into a list, which uses double quotes here, then each command that you would put in there. So python, -m, http.server, and then 8000. So this list makes the spaces and all that. So this is the actual command line you would run on your terminal or something like that. So if you were to open up your terminal and let's say you had Python installed, this is how you'd run it. When it comes into Dockerfile, this is one of the ways we can run a command like this. So I'm going to go ahead and run this command now. The way I'm going to do it is fairly straightforward. First off, we need to run the build command because I made a change to the Dockerfile. So I want to go ahead and build out this new container image. Then I want to run it. Now, once again, I could run it as an interactive terminal just like that. What we see as soon as I make it an interactive terminal, we can see that it's running an HTTP server on this port. But there's a problem. If I try to open this on my local web browser, it says it cannot be reached. This is because Docker containers themselves need to grant permission to allow a port to be opened on my local machine. So in other words, my local machine needs to say, hey, it's okay that this container runs on this particular port. The container itself is running on a port within that container. That starts to get a little confusing, but the idea here is as soon as we want to use a port like this, we need to make sure that we have a Docker command that recognizes that. And that Docker command, we can still use IT as an interactive terminal, is -p, and then whatever port we want on our local host, which I'll go ahead and say port 8080, then we want to map that to the port that the container host is running on, which is 8000. Now, I could even change this. Let's change it and make it even more dramatic to port 3000 and then port 8000. So this is how I want it to run. These are the different arguments that we have in here. And then finally, we need that same container image. So once again, I can go ahead and now call it with that mapping. So what the actual container is saying, the Python code is logging out this information, but my actual container image is only available at 3000. So if I go to 3000 on my local machine, 0003000, I now see this directory listing, which is kind of strange, but it does show me that. And so if I wanted to change it to 8000, you might guess what it would be. We can copy this. We change that to 8000 then, and then I'm going to go ahead and hit Control-C as in interrupt the container image itself. And then we can now change the port to being 8000. So my local computer is opening up port 8000 to my container, which happens to be running at the same port. So if I open that up now, 8000 is running, whereas 3000 is no longer running. We'll talk about these ports a lot, but remembering all of this stuff, as well as building, running, all of the different changes you might need to make starts to get a little cumbersome within just a Dockerfile. So we want to go a little bit further than that. But before we do, I will mention I'm starting to build out this Docker commands.markdown file that will show you all of the different commands that we're working on in this case, right? So that's a big part of this, is to make sure that we remember what these commands are if we ever need to use them. Now, of course, you could always just go into a chat, like an AI chat. You can use Claude. You can go ahead and say what this is. I do encourage you to do that as much as possible so you get cleared up on all of these different things. Now, before we jump into this one, I will mention all of the code will be on this GitHub repo. I just added it, so you'll see a few extra files in here, but overall, it's basically the same spot as to where we were. We're going to now take a look at Docker Compose. What that's going to help us do is it's going to help us remember various arguments that you might want on your actual Docker commands. It will also help manage more than one container at a time for the local repository or for the local project that you're working on. It's a really effective tool for all sorts of reasons. So let's take a look at the bare bones. First and foremost, I'm going to go ahead and come in here and do compose.yaml. Now, there are other ways on how you can declare this file. Just like the Dockerfile itself, there's other ways to declare it as well, which you might see out there in the wild, docker-compose. You also might see YAML as YML, not YAML. It is a fairly flexible file format, but the idea here is inside of this format, we want to use valid YAML. This is just a key value pair that is also fairly straightforward. Now, the very first key we need to declare is simply services. Docker Compose expects services, expects this. The next one, we get to decide what that key value is going to be. In fact, we can add in a bunch of key values for the names that we want to call our services. What's common is you'll see app, as in the application is just simply app. But we could call this my awesome app if we wanted to, but just calling it app just helps shortcut that a little bit. So this is a custom key name. The next ones are not custom. So basically everything else is essentially required for actually designing a container app inside of Docker Compose. So what we can do in here is we can decide our image. So let's say, for instance, we want to grab our image of Python. I'll go ahead and grab this one right here. The exact same image that we've been working off of. And that's it. I'm just going to save just those two things. Save it. And now inside of my terminal window here, I'm going to go ahead and run Docker Compose up and hit enter. And so what it's going to do here is it's going to run some things. And every once in a while, you'll see this command that you've got orphan containers here. This is just because of my own testing. So you can always remove those as you see fit. Okay, that's kind of the idea. Now, keep in mind that this container image does not have anything blocking it. It does not prevent it from always running. So this right here will make sure that the container always runs. We can do that same thing inside of Docker Compose with the command. We can actually run that same exact command, and now I could just write it out like this, right? There it is. So now if I go to run Docker Compose up and hit enter, it should now block the actual server from just opening and closing. So before I had that command, it opened up and closed it. So if I close this out with Control C, this will stop out the container itself. This is kind of the long way of doing it, but it does stop it eventually. I hit Control C again, and then I'll go ahead and run. I'm going to comment out this command again just to show you this with that remove orphans on there. Hit enter, it comes up, and then it'll eventually go basically right down. Assuming that I saved everything, which I might have not. Let's go ahead and try it again. There it goes. So we get this app exit code 0, where the other one sort of prevented it from moving. So let's bring back that command in. And what I want to do is I want to enrich my actual settings to have some sort of port, right? I want to make sure that this port is accessible. So once again, with this command in here, if I were to run it, I probably don't need to remove the orphans now, but let's go ahead and run up, and I'll go back into my local host here, and I'll go to 8,000. It cannot be reached. Again, my local system does not have any ports attached to port 8,000, so I need to make the mapping for it, which I can do in Docker Compose with just simply ports, and then this is a list of items, so we can have a bunch of ports mapped to other ports. So we just declare the mapping we want. So like if we wanted port 8000 mapped to port 8000, we could. We could even try to do multiple mappings at once. So I'll do that with those two mappings right there. Either way, both of them are going to the internal port of 8000, which is the same one as this right here. If I change this to 8001, I would want to change these as well. Okay. So with that in mind, I'm going to go ahead and leave it as is. I want to make sure I'm saving compose.yaml. If you don't save it, which I do constantly with Command S, if you don't save it, then this next step won't actually work correctly. I'm going to go ahead and open up a new terminal window in here. I did have some tests, so I'll go ahead and close out. I'm going to close out all terminal windows and just run Docker Compose down and hit enter, and that should take down that container for me. So Docker Compose up, Docker Compose down. Very straightforward in terms of the commands themselves, which I will have in dockercommands.md. There will be a bunch of them in here as well related to Docker Compose also. Okay, so what we've got in here is the entire settings that we want. Let's go ahead and do our Docker Compose up now, hit enter. Now we see that it should be just kind of chilling here. It shouldn't actually close down just yet. And now if I go into my browser, I should be able to see this directory listing again at port 8000 and also at port 3000. It's in both places because I mapped my local machine's port to that container port just like that. So what we did here was basically take over what we were doing with this command right here and this command. We just stacked multiple ports, which you could do with Docker directly. But now it's just one command that we need to remember, Docker Compose up, and it just works. Now, even if you remembered the actual Docker command, using Docker Compose is great because you can also do app2 and quite literally have basically all of the same sort of stuff on there, but just change maybe the ports, because you can't have the same port multiple times. You can only use that port once. So let's change this one to port 8001. Same exact app, everything's the same about it. So once again, what we want to do is we want to take it down, Docker Compose down, and then we're going to go ahead and bring it back up, in which case it will go ahead and give me another port. So the important parts of this is our custom app names. The service name itself needs to be unique. The next thing that needs to be unique is the port mapping. If the port is taken on your system at large, if any other app, regardless of if it's Docker or not, is using that port, you will not be able to use that port, right? It will cause errors or it just won't be accessible. So if we go ahead and do Docker Compose up now, we can see I've got two apps in here, two containers running, app 1 and app 2. Those are also taking up those two ports, right? So if we do 3000, we look at port 8000, we look at port 8001, we should see all of the same sort of stuff. So this is incredibly nice about Docker Compose. It's literally running two container images now just by adding in another service, which really opens up the game for us quite a bit, because I could change this to a database. Maybe this is our Postgres database. Maybe the next one is like our redis database, right? We can start building out all of those things on there. Now, I'm not going to do that just yet, but that's kind of the idea, is you can build out every sort of dependency your app might need to be able to run correctly, right? So in this case, we have these two apps in here. Typically speaking, when you change Docker Compose, especially if you're building out new services, you're going to want to bring down the old one. So Docker Compose down. Otherwise, you'll get that orphans thing that we saw before, which is not that hard. You can just use that flag of remove orphans. But anytime you want to change these things, let's say, for instance, it's going to be our backup app or something like that, you would just want to make sure that you take everything else down and then bring it back up whenever you change those custom key names, as well as pretty much anything in Docker Compose, especially in development. Let's build out a custom image for our app using Docker Compose. What I'm going to do is I'm going to get rid of app 2. We don't need that anymore. And then I'm going to go ahead and comment out image. Instead, what I'll have is simply build. Now I have some additional parameters I can add in here for building out our custom image. The very first one is simply the Dockerfile we want to use, which is going to be right next to compose.yaml, in which case I can just go ahead and declare Dockerfile. Let's say, for instance, I had a folder called Dockerfiles in here, and I wanted to go ahead and do example and call this a Dockerfile. I could quite literally use that same concept here and just do /Dockerfiles and then example, right? And so that's how you can actually declare other Docker files in here if you wanted to. Again, I don't want to do that right now, but I will at least show you that fact so you know that this is mostly just saying, hey, what Docker file do you want to use here, so we can go ahead and build it relative to compose.yaml. Next is the context as well. Where are we going to be building this Docker file? What context? Is going to be this local folder here. So I'm going to go ahead and save that. And as soon as I do this, now what I can do is run Docker Compose build, the same sort of idea as Docker build, but it just builds the app itself. Now I can run Docker Compose up again and then just let that go. Now, the other thing about this that's really cool is I can bring it down again. So Docker Compose down. And then once it is down, I can run a different command for Docker Compose up. I can do -- build in there. So that's going to take a moment for that to come down. So I'll just go ahead and do Docker Compose up -- build. This will rebuild the container image and then run it. So it kind of does both in one step, which is super nice. Okay, so the idea here then is I should be able to go to port 8000 once again and see the directory listing. So 8000 and 3000 because we have both of those ports in there. And that's it. That's all I need to do to change it just slightly, which is super cool. But the real question is, how do we actually make changes as to what's being displayed on this web page, right? How do I do that now? Let's take a look. Let's go ahead and change what our container image is displaying in here, because right now it does not look great. So what I want to do here is I want to go ahead and do Docker Compose run, and the app I want to run, or the service I want to run, is just simply app. And then I want to go into bin/bash. And I'm going to go ahead and hit enter, and I'll do ls here. And what I see is, well, quite literally the same stuff that's in here, right? And I could probably even do cat docker env, which is this right here. I can click on that. It probably downloads it, says 0 bytes, all of that. So the idea here is our Docker application right now is just listing all of this stuff out. That's quite literally what this server is doing, this HTTP server. So what I want to do is I want to change that a little bit. I'm going to go into home. I'm going to cd into home, list things out here. I'm just going to go ahead and echo something like hello to, let's say, for instance, index.html. So I'm just making a standard HTML page in here, index.html. Now, if I go back into my other container that's been running and hit home, I don't see that file in there at all. So the reason for this is how containers work. They are, number one, ephemeral. That means they get destroyed and built a ton of times. They do not persist at all. Now, you can add things that persist. You can add something called volumes that will persist, but the container itself is meant to be destroyed. It's meant to be destroyed and brought back up. The other thing is, whenever I run a container, especially this command right here, it's actually creating a new instance of that container. It's kind of like opening up a new browser window. that browser window is not the same one that's opened to your other one. That's kind of the idea. But we can see this in action right here, right? So on one container, I actually have this index page in here, which is still there. On the other container that's actually running in a different way, it doesn't actually have that. And what I mean by is running in a different way is this right here is running bin/bash. This is the command it's running. The other one is running this command right here. It just happens to be accessible in two places. So all I want to do right now is I want to modify my Dockerfile so that it has an index page similar to what we've got here. And then it also has the home folder as that main root folder. Let's see what that looks like. First off, inside of my Dockerfile, what I want to do here is I want to do the run command. And all I'm going to do is say echo, and we'll go ahead and say hello into index.html. But is that actually where I want it to be? But let's go ahead and just do just this, just to see what happens. So I'm going to exit out of this running container. I'm going to go ahead and do docker compose down to take the other one down. And then in here, I'll just hit Control-C just to make sure that's working. Now, since I made changes to the Dockerfile, I'm going to go ahead and do docker compose up -- build. Hit enter. This will rebuild our container image as we see here. And so hopefully with this run hello to index.html, it changes what's being seen on our web browser. So let's go back into our local host, the root value there at 8,000, hit enter. There it is. It now has a web page running. If I were to change the page to something different, we get a 404 because it just simply does not exist. This is a really good start, but not quite where we want to be. And I'll say why, because we're going to go back into our bin/bash. So I'll press up a few times, back into bin/bash, into the root of our container. We list things out. We see that new index.html. If you were able to scroll back, you would be able to see that that index.html was not there, but rather all of the other things were. So I actually want to change the location as to where I'm going to store index.html. Now, there's a lot of different ways on how you could do this. One of those ways is by creating a working directory inside of here, which I'm going to call just simply app. Notice in my directories right now, there's nothing called app. Sometimes they're called app, sometimes it's just simply called code. I'll just leave it in as app. I'm purposely putting it before the run command so that the run command goes inside of this working directory. Similar to like doing make dir -p of app and then cd into app and then running this command of hello like that. That's essentially what I'm doing. Let's exit out of here. We'll do our docker compose and down. I'm going to go ahead and add in that remove orphans flag here just to make sure that it's taking all of my other apps away. And then I'm going to go ahead and close out my container here. I'm not going to gracefully stop it. I'll just hit Control-C a few times because I really want to get to this right here where I'm building it up. And then I'm going to go ahead and take a look at my project here. It's still saying hello. Didn't really seem to change much here, but it did run all of the different commands. It ran workdir of app, and then it ran that hello world. Once again, I want to enter into a new container here with run app bin bash. Now I see that I'm inside of app. If I list things out in there, I see it says index.html. I could go back into where I was at one point. Index.html is now gone. App is now the thing that's in there and it's now working. So I really made a very simple like HTML, static HTML web server running right here. So in many ways, you could actually have a Next.js application probably running right in here. It might not work perfectly because you might need Node, but the idea overall is you could have at least a React, static app in here, or like a Vue static app in here, or some sort of JavaScript app, or just plain old HTML like we have. Now, this is not good HTML at all. That's not really the point. The point here is to see that, oh, cool, I have Python on this container. I created a working directory and I ran a very specific Linux command, right? That's a Linux command right there. That command then created a HTML file for me. And then at the very end of the day, I ran a command to make sure that that gets served correctly as an HTML document. No longer is it serving the other things. Like I can't do /app or something. I can't do that. It just won't allow for me to browse those files any longer. I can't see the container system files any longer because of what I've got here, which is pretty cool. But this is now getting to the point where, oh, cool, how do I replace this with my own code? let's take a look at how we can copy our local files into our container image as it's being built. So the way this is done is we jump into our local folder here. I'm going to go ahead and call this my static HTML, something like that. You can call it anything you'd like. So inside of here, I'll go ahead and actually add in something like abc.html. And I'll go ahead and do an H1 here and do just simply ABC. So the idea is I want to bring this folder in to my container. The way we do that is twofold. I can just go ahead and do something like copy, and then we're going to go ahead and my local folder to my container folder. That's kind of the idea that we want to use with copy. So we'll go ahead and do copy. The local folder, of course, is static HTML, which I'll do a /. The reason I'm doing // is because it's relative to this Dockerfile. That's what the // will allow for. And it's going to be static HTML, which of course is this folder right here. And then where do I want to send it? Well, let's go ahead and send it into simply /static folder. Okay. And so static folder, this one just simply does not exist on the container. I already know this based off of what we saw before, but what I also want to do is run make dir -p of that static folder. I want to make sure that that one even exists. I'm going to get rid of the working directory for now. I'll leave that run command on for a moment, but overall this is what I've got. So I'm going to go ahead and save this. Now I'm going to go ahead and run docker compose up --build, make sure the whole thing's built out, and then we'll go ahead and take a look at our container image. And so what we should see in here at our local host, we see hello. Now we see the same issue that we saw before, which was this is just creating that index file for us. We don't want that. So let's go ahead and comment that one out now as well. I'm going to close out the server. I'm just going to do Control-C 2 times to do it quickly, and then we'll go ahead and run it again. Now if I rebuild it, I can now see all of my directories in here. We see static folders in here. If I go into static folder, I see abc.html. If I open that up, there's abc.html. So it's quite literally bringing this entire folder in to static folder. Now, that's not actually where I want it to go, but it is nice to see that it does work. And running make dir -p just ensures that that folder is there. It's possible that it's not there. This makes sure that it is. When you run workdir, it will always be there. Docker will know to make that folder itself. So now instead of copying it to the static folder, I'm going to copy it somewhere else. I'll go ahead and copy it where? Well, I'm going to go ahead and do static HTML into simply app, into the working directory. So there's actually a couple different ways on how we could do this as well. I could do it that way, or I could just do it at .period, which these actually have the same destination in this case. But if you call this code, then these would not have the same destination. One would be in app, one would be in code, which maybe is something you want to do. But in our case, we're just leaving it in as one single working directory, in which case these have the same destination in here altogether. And that's not, same destination is /app. Great. And of course, if I wanted the app itself to actually show an index file, I need to bring in one in here. But before I do, let's go ahead and copy it now. Once again, I'll bring everything down quickly. I'll refresh in here. And if I look inside of the root now, so in localhost, I still see directory listing simply because I don't have index.html. Index.html is how all static HTML websites work. So you need to have index.html in here. So if this was 1998, this would have worked really well. This would have been super cool if this was working this way, especially with Docker. But the idea is this folder is 1998. That's the idea there. So I'm gonna go ahead and close this out again, and we'll bring it back up. I refresh in here. Now it says hello world. And if I go to /abc.html, I should see that. And if I wanted to add additional ones like about and hello about, we say that. If I'm adding additional folders like that or files, anything in there, I need to rebuild the application. I need to rebuild the container itself. Otherwise, it won't actually come in. There are ways to modify that itself, but now I'm adding in additional files in here, and we'll go ahead and say, contact us like that. And then if I go back into the app and try and do contact, I get an error response because the container itself doesn't know about these files, right? So I need to rebuild it, and there we go. And so now what we see is how to build out our own static HTML web page with a standardized Dockerfile. It's really not that complicated from my perspective. We created a working directory where we want to run all of the future commands in. Then we actually copied a bunch of static HTML files in here into that working directory. Then we ran the command of python -m HTTP server 8000. This is a proper container image. I could build this and deploy it all day long. The actual static HTML could be built with Vue, React. It could be built in a lot of different ways, right? So that part is not really that big of a deal, the actual static. The part that's going to be a big deal is turning this into a programming-based one. So like a Python application, a Python web application that has dynamic HTML as well as databases and all sorts of stuff that is way better than just static HTML for a lot of use cases like the one we want to build. But the point here is being able to attach your local code as you see fit. But I want to modify it slightly so that our Docker Compose file can actually understand a few different things about this static HTML. At some point, you might want to use Docker Compose for a front-end web application and a back-end web application, in which case you definitely can, and you'll probably start to rethink how you do compose.yaml. In other words, you probably won't have just one Docker file. You'll probably have a few of them. So let's take a look at a few different strategies on how you could do this. Number one, the way I would like to do it would be to change the name of the Docker file, which would be something like dockerfile.static, which in my case would be related to the static file here. Now you'll notice that the actual syntax highlighting changes a little bit. So some people recommend using Dockerfile as the extension. So you would do something more like static.dockerfile, in which case it still has the Docker-ness of it all. Feel free to pick either one. Either way, if Dockerfile's in the name, most people that know Docker know how to modify those things. So you do something like this where it's static.dockerfile, and that's it. So you could then have a bunch of different Docker files all in there. Now, this is one way to do it for sure. Another way to do it would be to maybe move the Docker file into the folder that it's actually starting to work with. And in which case, inside of that folder, I would do something a little different and I would create SRC in there, and then I would move all of my source code inside of SRC, just like that. So I made pretty drastic changes to this app itself. First off, in compose.yaml, we want to change the build context to the folder of simply /static HTML in there. I won't need to change the Dockerfile path because it's inside of that context. It lives in that context. But in that Dockerfile, I need to change a number of things. Well, maybe just one thing, but the idea here is we've got our Python file or our Python image, our working directory. Then we need to see our destination in here. So this destination is relative to the Dockerfile itself. We don't have static HTML anymore. We now have just simply SRC in here. And that's it. Those are really the only changes you would need to do. But now our compose.yaml is a little bit tighter. Our entire project is a little bit tighter because the entire build context is now in the static folder in here altogether. In which case now I can run this again. We'll do docker and compose up -- build. We should see everything work just fine, right? And it should build everything as it did before. We see our new copy command in here showing us that it actually is working the way we wanted to. So just changing the context made a big difference in terms of how that app was built. And so that's it. I mean, going forward, we would just start building out our different services and have different folders for those different services. So in this one, I would call this my static HTML app or something along those lines. I would pull down the old one because this isn't an app, it's just static HTML. So calling it that as far as a service makes a whole lot of sense. So you probably want to make it make sense as much as you possibly can, even if Python is actually running the static HTML. The app itself or the code itself is very simplistic and it's all static HTML itself, which is hopefully very obvious at this point. Now, if you use something like Nginx, you can take the same concept as well. Nginx is pretty cool in terms of load balancing on these services. That's outside of the scope of what we're going to be building here. Mostly this is just about being able to set the parameters to start building out a full-on Python web application and also build out the capabilities for an agent in the very near future as well. Mounting a local volume to our Docker container will help us in a big way during development mode. Let's see what I mean by this. First off, you look at our web page, it says hello world. Next, we want to change it to being hello world. Let's say hello world again, exclamation mark. We save that. We go to refresh on our page here. Nothing changes. So what to do about this? How do we actually make those changes? Well, you might remember we bring down our container, right? I'm going to force it stopped, and then I'm going to go ahead and bring it back up, but make sure I use -- build to make sure that it does rebuild this container. And if for some reason it's not actually refreshing, make sure you save that index file. You could also go into the console here by inspecting and then going into network and hitting disable cache. That will probably clear it out as well. But overall, the idea here is we have to rebuild our container if we want to kind of refresh these static files. So the way we solve this is by just using a local directory. What's that local directory? We use this one right here, src. So in other words, I can actually turn that into a volume that I'm mounting into this container. Think of it a little bit like an external drive that you're just attaching to the container itself, but it's not an external drive, it's just this folder right here. So we're gonna go ahead and copy that relative path. I'll use // so it's relative to this actual file. We use static HTML src. Then we put a colon here, and then we want to decide where we're going to put it into the container itself. Now, you might recall what that is going to be, but it's a lot easier by just looking at the Dockerfile. We see we've got our working directory here, and then that same src folder is going into that working directory. So this is the destination then. So we're going to come back in here and just do that, /app. And so whatever that working directory is, but the idea here is, of course, if you changed it to /app abc123, then you would want to include maybe that whole thing. So it would be something like /app/abc/123. I think that's what we said. It would be all of those, the two apps in there and all that. But of course, we don't have all that. We just have app. So we're going to just use that single folder in there as well. So what this will do is it will allow for us to attach our local file system into our container in a way that makes a whole lot of sense for this project. But let's actually see it in action. So I'm going to go ahead and take it down. I'm going to take down that container. And now what I'm going to do is not call build. I'll just do docker compose up, hit enter. And so it did say it recreated this, but I don't see any build process. So let's go back into our project here. And it still says hello world again. Let's just change it to hello world with volumes. Save that, refresh, there we go. So this is a static way to make changes to our static files. Now I will give one caveat here. The way this command is running, this Python HTTP server, will allow for this to dynamically change like that. So if we make a change to the file, the actual server itself is just rendering that file. Whatever the current state of that file is, will be rendered. If we were using something like FastAPI, Django, or Flask, it may not necessarily work this way by default. There might be other things you might need to change. A lot of times you'll see something like a watch command inside of there, or like a reload command in there as well. So those commands are often necessary to make sure that this kind of thing works if you were to change those files after you mount them. Now we'll see that again in the future. I just wanted to mention it now because this is still just a static website with some static volume in here. Now the thing that is not managed by Docker at this point is this volume. So if I were to take it down with, let's say for instance, if I run docker compose down, there's another flag where you can do -v. This will take down volumes if Docker manages it. Docker does not manage this volume. We will see managed volumes later as well, but the idea is every once in a while you might want to remove old volumes that might have stuff that you just don't need anymore, like a database you just want to clear out, for example. That might happen at some point. So just be aware of this fact that this will take down volumes except for the ones you manage yourself. So that's actually pretty nice. We're now going to build out our backend using Python and FastAPI. So Python, of course, is going to be the programming language that will run the code. FastAPI is the pre-built code that will allow for us to build a web application versus a static website. Now, a web application itself uses code to respond to what should be shown on a web page or some sort of response. More to that in a little bit. But for now, what we need to do, of course, is set up the actual build process. Now, of course, you could always download Python and run it yourself, But the idea here is I want to use Docker Compose in tandem. So we develop this with Docker Compose. So I'm going to go ahead and do our backend folder here. Inside of this folder, I'm actually going to go ahead and copy our original Dockerfile here. Now I could leave it as static.dockerfile. I could also call it something like dev.dockerfile, and then maybe eventually have something like prod.dockerfile. But I'm going to make it nice and simple on myself, as I would when I'm doing these production applications anyway, including in development mode. And that's quite literally just calling it Dockerfile. That's it. So that's where I want to start. I also do want to have an SRC folder. So you notice that the patterns are very similar to what we did with the static HTML. What we need to do is just modify how we use our Dockerfile directly. I can leave pretty much everything else as is. The SRC folder doesn't have anything yet, so we of course need to build that, but I'm going to leave it as is for just the moment. So inside of our Docker Compose then, I'm going to go ahead and copy everything from static HTML, paste this on in. I'll probably get rid of some of the comments in here though, and then I'll go ahead and bring in backend as the name of our service, or we could call it like our backend API, or simply just our app, right? I'm not sure if I will have a front end, but I'll certainly have a backend that I'll have, so I'll just leave it in as simply backend. Again, you can name it how you see fit. That is a custom key name. Next up is our build context, which of course is the folder of backend. This time our Dockerfile is different. Our ports will also need to be different if we want to keep the static HTML, in which case I actually do want to keep it. So I'm going to go ahead and get rid of this port right here. And I'm just going to go ahead and change this to port 8080. We'll leave port 8000 for just a moment. And then of course the volumes themselves are going to be from the backend as well. So not a huge difference from what we did before. So if we go ahead and save everything here, we are on the right track. Next up, what I'm going to do is Docker Compose down. Let's make sure that everything is brought down if it's not already. Then Docker Compose and up, and I'll use -- build to make sure that everything is built. So what we should see is two different applications running. Two different containers are in here now. One is, of course, our backend. The other one is our static one. So if we were to go to port 8080 on our local host, we should see nothing, right? Just this empty directory listing. That's absolutely what we want to change. So how do we go about changing it is really the question here. How do we build a Python web application? Well, to me, it starts with the actual third-party packages we're going to use. So inside of this backend here, we're going to create a file called requirements.txt. And here is where we're going to declare our Python requirements. So where we find that is a site called PyPy. So pypy.org. This is a Python-specific package finder or index. So if you do a quick search for FastAPI in here, you will end up seeing a bunch of versions of FastAPI. But of course, this is the official version right here. Now, there's a lot of different ways on how you can find out that this is the official version, but a lot of times it's just the pip install FastAPI command is going to show us exactly what that is. Now, this is another case as to when you want to use a very specific version, unless of course you're just testing a bunch of things out. In my case, I'll use a specific version so you can see how it's done. And so we can go into release history here. This is the current version right there. So that's the version we want to go ahead and copy, which we can then select. And that's the version that I'm going to copy right here. And I'm going to bring that right into requirements.txt. So with that version in mind, I'm also going to go ahead and bring in uviacorn in here, and we'll put in standard. More on this in a little bit. But for now, we've got two different packages that we want to have available to our container to actually run this application. So this means we need to adjust our Dockerfile. Our Dockerfile is how we set the parameters on how this thing's going to work and run. We have already seen that, but now we're introducing third-party Python packages that we haven't seen before. So all I'm going to do here is I'm going to get rid of a lot of these old comments that we no longer need because we will be changing them very, very soon. Okay, so let's go ahead and see what it is that we need to change. Well, first and foremost, we are copying the SRC folder. We are not copying requirements here. So I want to make sure that I copy those as well. So I'm going to go ahead and do copy, and we want to grab in requirements.txt, and then we want to put it in some sort of destination. In my case, I'm going to put it into a temporary folder at requirements.txt. So this temporary folder is a very Linux thing. But the reason I'm putting it into the temporary folder is because it doesn't need to live next to the source code. It can be in temporary, it can be in something called OTP, but the idea is we want to have it somewhere else that's not right next to the source code itself so that we can install it later. So now that we've got these requirements, we need to think about how we can install these requirements. Now, I did mention that there's the Python package like index, PyPy. This pip command is how you install third-party packages. So what you would then do is right underneath copy, you would do run pip install -r, then requirements.txt. But the specific absolute path to the requirements.txt that we're using, which is going to be the destination we decided. Again, remember, copy is copy local folder or file to container destination, right? That's how that works. And so then our run command, run within container while building, right? Okay, so that's the point here. So if I were to save this, we are getting closer to what we need to do. So let's go ahead and take down our backends, and I'll go ahead and build it back up. And what we'll see here is it copied over those requirements, and then it actually ran the installation for those requirements. But we have a big problem here, especially those of you who know Python really well, is I'm actually installing these requirements on the system at large. In other words, I'm not isolating Python from other things that this system might be using within Python. So there's another layer of isolation we need to add beyond the Docker container, which is called a virtual environment. So before I even run all of this stuff, what I want to do is I want to create a virtual environment. So we'll go ahead and create a Python virtual environment. And then this is to isolate Python from system level Python. That's pretty much it. So our Python app, and installs from a system level Python. So of course, the way we do this then is by running Python. You could use Python 3 in this case, but since we're using the Python image, I think just pure Python should work just fine. And then we use the built-in module called venv. And then we want to actually put our virtual environment in a very specific place, which I'm going to go ahead and put it into OPT, which is a very common place for optional software in a Linux environment, which of course is what powers a Docker container. So this will create it in that location. So that means then when we want to run pip, we would do something like opt venv bin/pip. This would be one way to install into those virtual environment itself, or we can add that virtual environment into our environment variables, in which case we do env path equals to the opt venv/bin $path. So these two will ensure that everything after is working based off of this virtual environment, and that is the point for this. This is the Python path itself, which will use the virtual environment version. So this pip install will now use that virtual environment version as well. Great. So this creates that virtual environment. This command down here is also using that virtual environment. So once again, we'll go ahead and save this, and we just want to make sure that it's actually building things up. And so we're going to go ahead and run that, and we can see that it looks like everything worked just fine. It is doing the installations. It's doing a bunch of installations based off of the requirements file itself, and then it's going to go ahead and start running, which is great. And of course, if we go back to 8080, what we should see at localhost is still nothing in there. We don't have any code in there just yet, which we'll do very soon. Now, before we get there though, all I want to check here is Docker Compose run. We want to actually take a look inside of the backend. So I'll go to the service name itself, and then we'll do bin/bash. This of course gives me root access into the container itself, in which case I can cd into opt/venv. This is giving me that virtual environment stuff, and I can cd into the bin and see what's in there. Here's all of the different commands that are built into that bin, like uviacorn, we'll see that one soon. FastAPI, that's another command that you can use. But the idea here is these are all of the commands that came in as a result of our virtual environment and as a result of our requirements being installed. We can also see the requirements that were installed by going into lib and going into, let's say, Python 3.13, and then going into site packages, and then seeing all of those Python packages that were installed. And of course, if you go into any of them, like FastAPI, you can actually see Python code in here by doing cat and then maybe taking a look at that Python code just like that. And that shows you some Python code that's already installed on your virtual environment inside of your container that is running inside of that app. So we got a lot of good stuff in there going on. And these steps are exactly what you would need to do if you were deploying to a Linux virtual machine outside of a Docker container. You would need to install Python. You would need to create a virtual environment, likely at this location. You would want to add that virtual environment to the Python path. Then you would add in your own app-specific things, like where you want the working directory to be and how you want things to be installed. Okay, so really the final step here is just to create a FastAPI application, in which case I'll kind of breeze through it here just a little bit. The idea being that it's going to be really simple. So we're going to go ahead and do from FastAPI. We're going to import the FastAPI class. We're going to declare our first FastAPI application, and then we're going to go ahead and do app.get the root here, and then I'm going to define read index, and this is just going to return back a dictionary of hello and world. Okay, so my text editor is saying, hey, I can't find FastAPI. That's because I actually don't have a virtual environment on my local machine. It's only in Docker. So in that case, it is on my local machine, but not in this local directory. So my text editor, my code editor doesn't know what's going on. That's what's going on there. Okay, so now I have a FastAPI application. The one slight change I want to make is the actual command I'm going to use here for this FastAPI application. So the command itself is no longer Python, but rather it's going to be uviacorn, and then we use main as in main.py, app. That app itself is going to be this app right here. So if I called this ABC123, I would need to call this ABC123. And then the same would be true if we renamed main.py. But of course, I'm going to stick with app itself. Make sure you save it as well. So this will allow for me to run the app. Then I want to declare something called host, which is 0.0.0. And then I'm going to go ahead and do port. And then the port I want this to run at, which is currently on 8,000. So I'll stick with that one. I'll explain those two things in just a moment. But the idea here is I want to go ahead and take down everything. We're going to go ahead and bring everything back up, build it. We'll go ahead and take a look at localhost 8080. There's our hello world command. Okay, so back into this command right here real quick. What we've got is this host. This allows our Docker container to allow our FastAPI application to run on our local host. If I got rid of that, saved it, brought everything down, rebuilt it, it would not be reachable. I need to make sure that it's reachable, so I bind it to any host that's possible. Anyone that's out there, whether it's localhost, whether it's 127, any of them. This just binds it to all of them. It just opens it up, which is important for Docker itself. This doesn't mean that the internet can access it at all. It just means that it can be accessed at any port that's actually running it, or any host that's actually running it. And then of course the port is the one that we want our container to be bound to as well, in which case once we actually have localhost running, our actual 8080 should now work as well with that hello world command altogether. Okay, so we went through a lot of stuff really quickly, and I didn't really cover what's going on with FastAPI. We will definitely come back to that. But this right here is a minimal API application within Python. This is why FastAPI I think is so popular, is because we now have an API. It's a REST API, it's ready to go. We just need to build on top of this. Our Dockerfile is not a whole lot different than what we did before. Notice our old command is still in there because that old command still technically works, right? So in our compose.yaml, if I were to comment out our new command, we could actually see that file that's in there. So we can refresh in here and we can see everything that's coming through on our actual project. And notice that py cache is in there as well, even if you don't want it to be. But there we go. So we now have a lot of good stuff in here in terms of our application. We are ready to start building out more on top of this. We're now going to take a look at the Docker Compose watch mode. Now, if you remember back to when we changed the HTML files with that attached volume, those changes were reflected automatically. But if we do the same thing with Python, is it automatic? Let's take a look. So if we jump into our HTML, of course, I can change hello world exclamation mark and take a look, it changes. If I do that same thing in our FastAPI application and do hello world again, save it, go back into our project, it doesn't change. So the Python approach on how you could make that change and make sure that it is changing is going to be inside of our command for uviacorn. Uviacorn is just a web server interface for asynchronous programs like FastAPI can be, but the idea is it has a command called --reload, in which case we could rebuild our container again, and we can see now it says watching for file changes in that directory. And so if I look in my application, it says hello world again. And if I get rid of again here and save it, FastAPI and UVacorn notice those changes and reloads the application, and there we go. But what if I made a change to requirements.txt, like requests? Now what? Does it make those changes? Does it actually do anything? The answer, of course, is no. We would actually have to bring down our entire Docker Compose, or at the very least, rebuild this application itself. So what we can do instead is we can build in a new parameter here that would be called develop. So inside of your develop mode, you can do develop called watch, and you can add in a bunch of different actions. So the first action maybe would be something like rebuild. So when would we want to rebuild this container image? Well, it has everything to do with if we change requirements.txt, which I would just come in here and grab that absolute path. So if anything happens to requirements.txt, we want the entire container to be rebuilt because the Dockerfile itself uses requirements.txt to rebuild that container, right? There we go. Now, another thing we might want to do is maybe get rid of this reload here. So in addition to rebuild, we can do another thing called restart. So I got rid of reload for a reason, because now what I can do is just do the path backend src, and this will just restart that command. That's it. So it will just reload that command, and it will go based off of the backend change it in any form. Now, this is where it's a little bit closer to how the static file was doing, but it just reruns this command. That's it. That's all it's doing. And so now we've got a bunch of different actions that we can use, and we'll see what this does in just a moment. But I'll go ahead and copy this, and I'll bring one more in, and that is going to be rebuilding if our Dockerfile changes as well. Now, we could do the same develop command into our static HTML if we wanted to as well, but if we don't do it, it's totally okay. So let's go ahead and see what this looks like. Now what we would do is do Docker Compose and then -- watch, or Docker Compose up -- watch. And then we hit enter. Now it's going to go ahead and watch this stuff. So let's see this. We see that it's watch enabled just on that one single backend. We can actually come in here into our requirements.txt. Let's get rid of requests now. I'll save that. And now what it's going to show me is rebuilding service after changes were detected. Great. So it removed requests in here from requirements.txt. I added it again, and now it's going through this process again. It actually closed out the server and rebuilt. And so now, to verify this, we can actually go into our Docker Compose command. So Docker Compose run backend bin/bash, and then I can go into Python and just import requests. And of course, you could try the same thing out with other packages if you wanted to. I just put in requests as a popular way to do, HTTP requests in there. Now, you might get some errors in here when it comes to rebuilding, because it actually stops the server dramatically and then rebuilds it. That's pretty much the point. The next thing is, of course, just checking this one. We would say hello world again. We save that, and then that restarts that server. It will reboot that server. It's not quite the same thing as what UVacorn was doing, but it is restarting the server itself, or it's restarting the container itself, which then restarts the server as well. So you could use either one. You could also just get rid of this restart altogether and only use reload, which would be probably a little bit more efficient in terms of making sure this is working. But the problem here is every once in a while you might want to actually reboot the entire thing, in which case I'll go ahead and just leave it out like that. Let's talk about dockerignore and maybe some of the challenges with mounting volumes with Docker Compose and what to do about it. So first and foremost, bring down Docker Compose itself and remove all of the orphans. So one of the things you'll notice is this py cache here. If I were to get rid of that py cache, just delete it altogether, and then run Docker Compose up, watch or build or either one, you'll see py cache come back. That's because the way the volume mounting is a two-way sync, right? So if you make a change in the container, that change will be reflected in your local code. If you make a change in your local code, that change will be reflected in the container as well. That's what that volume mount is. It does both things, just like that external hard drive analogy I mentioned before. So there is a way around this that you don't necessarily use this volume mount. Instead, you use something slightly different, which is called the action of sync. When you do sync, you can then add in a target where you want files to sync. So your local folder to wherever you want it to go. So if I comment out the volumes now and then bring back in the command itself, I bring back reload, I can see this in action. So if I delete py cache here, let's go and delete it. And then let me just bring everything down. I'm going to have to delete it again because I didn't bring everything down in time. Let's go ahead and bring things back up. Now we don't have that volume mount, but we do have this sync command in here going to the same location. So if we take a look at our app here, we see that it says hello world again. We can go back into our app and make some changes here and just hello world. Notice that we did a refresh here. It synced it when one change was made. I refresh in here. Now it's showing those synced items, which is pretty great. And also py cache is not showing up. So one of the things it's also not necessarily going to do is bring in everything you might want. So for example, let's go ahead and do an ignore me folder here. And inside of here, I'm going to go ahead and do test.txt. And then I'll go and say hello there or something inside of that file. I do see that it was syncing this service. So it seems that things were changed. So let's go ahead and run our backend. So we'll do our docker compose run backend bin/bash. We list things out. It's not actually in there. So it's not the same as the volume mount in this case, right? It is attempting to sync things, but we would probably have to rebuild that location. So one of the things you would then potentially do is you would rebuild it inside of one of these other paths. You would actually add in rebuild, right? So if we came in here and added this path in of, let's say, ignore me, you would add that folder in which case it would rebuild when you actually add stuff to it or make changes to it, right? So in other words, sync is not going to just sync all of your new folders. It'll sync things that already exist that basically have already been added within the Dockerfile itself with the copy and all that. So one of the things we want to do though is we want to make sure that we are ignoring this file or this folder in Git as well as in our Docker itself. So let's see what I mean by this. First off, we're going to go ahead and bring everything down, Docker compose down, and we'll go ahead and remove our orphans here. Feel free to wait if you'd like. I usually get impatient and just close things out here. So what I want to do is I want to ignore this file. The way you do that is with something called a .dockerignore. By far the easiest way in dockerignore is to do relative to the Dockerfile. You put it right next to the Dockerfile, the .dockerignore. And then inside of dockerignore, you want the relative path as well. So I'm going to go ahead and copy this path. The relative path in this case is going to be to this file, which is just simply src ignore me. As soon as you do that and you run docker compose up and then -- build, you could even do it in -watch. What's not going to happen is this folder will no longer be inside of our docker compose run backend bin/bash. We can see this, it's not in there. That's because of this dockerignore. Now I want you to test that same assumption with the volume as well. If I were to exit out of here and rebuild everything, let's go ahead and do that. What we end up getting is, hopefully not that surprising, that ignore me is actually in there. So the volumes don't care about ignore me at all. It just mounts the entire volume into your container as you see fit. Sync does care about it. Sync actually will only sync the things that make sense. So if I comment out those volumes again, exit out again, and then rebuild it, you could then change this and it will not make anything change, right? Let's go ahead and make sure we're doing watch. Let's just double check that. We've got watch in here. Let's make some changes into this test here and save it. Notice it's not triggering anything. If I go into main, hello worlded, it does do it, right? So sync does actually go off of dockerignore, volumes do not. Sync was added much later. Volumes was added early on to Docker and Docker Compose. So you can kind of pick and choose on how you go about doing that. There's also sync and reload, or rather sync and restart, not reload, that ends up doing it. But it starts to get a little bit muddy when it comes to wanting to sync your things that you're doing inside of the container. So when we come back into this container again, and I wanted to do echo like test to test or text.txt, that file no longer comes in. And you might want that file to come in. So it's kind of up to you on which approach that you're going to go ahead and take. Now, this sync plus restart I think is really useful, but locally, I typically use volumes. I still use the volumes because I want this stuff to be in there. If I don't want it in there, I just simply don't put it in there. My git ignore is when I go into production, and in which case things like py cache won't be in there, even if it's on my local environment itself. So Docker ignore can be really, really good, but git ignore is really going to be the thing that you want to really have dialed in when it comes to going into production, because then the Dockerfile will be building based off of what's in your Git repo. Your actual production code will be in there. So quite a bit different. But both things are really important to understand now that we've got that. But once again, I'll just go ahead and bring this back to being simply restart and getting rid of the reload in there and getting rid of this target. But sync and restart is really cool, and I do recommend checking it out from time to time. Secrets, passwords, API keys, or even runtime variables all are typically not written right in your code. It's actually best practice to never put any sensitive information in your code directly. There's a number of reasons for this, but the most obvious one is accidentally exposing it to the outside world. So if I do git remote -v here, I see here's my GitHub repo. This is a public repo. Anyone in the world would be able to see this and see the code that's in here. And if I leak any API keys, they would be able to see that as well. So the idea here is you never want to put your API keys directly in your code. So what's the next best option? Well, when it comes to API keys specifically, or secrets or passwords, you're going to want to use environment variables, or you could use a password manager or a secrets manager, like something that Google Cloud has, Amazon Web Services have, HashiCorp Vault. There's a lot of different ways to use those third-party secret managers. That's outside the scope of what we're doing here. Instead, what we want to do is we want to use environment variables at the bare minimum. This means that we actually remove it from the code directly and then inject it at runtime. So let's see what that looks like with Docker Compose. So if we open up Docker Compose on any backend service, we can declare two new keys in here. One, environment. And then in here, we'll put in some additional information. So like port equals to 8000, for example. Another one would be env file, in which case we would actually declare some sort of env file in here. So in this case, I'm using .env.sample, and also I'm going to go ahead and create that file just so that we have it. So we'll go ahead and say API key equals to ABC123. Okay, so notice that there's quotes around here. We'll come back to that in just a moment. Back into compose.yaml, we have this environment variable of port 8000. Now, this is not exactly a secret. You probably don't want to tell the world exactly what port you're on, but then again, it doesn't really matter, because when you go to any given web page, normally what it's expecting is port 80. So when you're going to an unsecure web page, it's port 80. When you go to a secure one like Docker Hub, and you actually just change it, let's go ahead and just go into this and do :443 and hit enter. The actual port itself will go away because it's already at that port, right? And so that's a key part of that, which you could test out as you see fit. So in other words, these environment variables, if you need runtime variables that just change a little bit, you can put them right here. So for example, we could say my project being like hello world, right? And so this is now another environment variable, but notice that I have quotes here. This will come into play in just a moment. So runtime variables, things that might slightly change what your application does, totally okay to have them in your compose.yaml. You could even have fallbacks in main.py, which we'll see in just a second as well. But the idea here is if you don't really care if somebody else has it, it can totally be in the environment variable. Of course, hopefully you do care that nobody else has your API keys, and in which case these would be injected at runtime. Let's take a look at this in code though now. Once we actually have these up here, what I can do is I'm going to bring down Docker Compose down, and then we'll bring it right back up so we can actually see something that's pretty cool. So the first level of this, it would be to go to Docker Compose run backend, go into bin/bash, and then just do echo, and then the environment variable preceded by a $sign. So $sign environment variable, hit enter, there's that value. If I do echo $ABC, it gives me nothing, right? So if you do it wrong, it will just give you nothing. So now next my project, there's hello world, great. And then if I do API key, there it is, right? So that's that API key right there. So we can now see that these environment variables are being injected at runtime. So if I actually wanted to see this in Python, it's actually really straightforward. We import a built-in package called OS. Inside of Python, we could do API key equals to os.environ.get and then API key. And then what the other one was that we might want to have is my project, for example. Let's go back in here, and then I'll go ahead and grab it exactly, os.environ.get, and then my project. So when it comes to environment variables like this, most of the time, every word or every letter is capitalized, and then the spaces turn into underscores. It's very rarely any other kind of casing. It's usually that. This is best practices. You'll see this all over the place. That doesn't mean it won't work in any other way. That's just typically the best practice because now, especially in Python, this is a constant. It's not something that we would change anywhere else, or at least that's how you would want to think of it. So when I said something about a fallback, right? So we've got this my project in here. What you can do with a fallback is if this is none, you could then go ahead and say, this is my project. So this kind of fallback value in there that you could then use. And of course, if I were to actually bring back my project in here, let's go ahead and call this project name, something like that. Save it. I think that I still have everything up and running. I can go back into my project here, and there it is. Okay, so we've got a new issue that you may or may not have expected. We've got a slash and a quote here. So what's happening is this is escaping this string, which is not what should have happened, right? So let's go back into compose.yaml, and for a moment, I'm just going to change this to other. So I'm going to go ahead and say that. We will bring down our actual Docker compose, and then I'll do it again. So this time it says this is my project. That, of course, is now our fallback. So that part's working great. But how come this other one was not working? Well, it has to do with these quotes here, especially in compose.yaml. So when you're using .env, what it will do is it will actually escape these values here, which is what those slashes are for, is to make sure that those quotes are basically included. So all you'd want to do here is just get rid of those quotes and do it like that. We would then restart this, and now it says it is hello world, and it's just a string. It's no longer having those escape quotes. So the point of actually defining these is you're going to use that environment variable, put it equals to whatever value, and notice there are no spacing whatsoever between them. The variable itself is often what you would name it inside of your project. You don't have to do it, like you could call it my API key and get a different variable. I like keeping them very consistent so they're easy to debug and diagnose where problems occur. And so there is our environment variables. But one thing you'll notice is in .env.sample, I do have quotes. So does my API key do the same thing? Let's go ahead and take a look. I'll go ahead and expose this API key right now. We'll save that. We'll take a look at our project. It does not do the same thing. So this is where .env is a little bit different than compose.yaml. You can have quotes, or you can also not have quotes, in which case with .env or with your environment variables, you'll probably have to bring everything down and bring it back up. That I've had the best use with altogether. So .env can have quotes on both sides or no quotes. You don't want one or the other, because if you have only one quote, let's see what that does. If we take a look at it, we get an error here that it doesn't have a value that's terminating it. Let's go ahead and put a quote on this side. Let's see if that does anything. This time it actually does roll up, and there we've got that escape quote once again. So just keep in mind that when you are adding in these environment variables, you don't need those quotes. That's typically the best practice overall. And this would be true if you're using a third-party service to manage your secrets as well. You will put it in there without any quotes as well. You put the raw value in, much like a password and all that. But we have one big issue, and that is I still exposed my API key, right? So that's the point of having these runtime environment variables, is so that you don't leak any of your API keys. But if you do something like this, all of that just falls apart. So what would be better to kind of validate or check that the API key has been set? Well, we just come in here and say if not API key, then we can raise something like a not implemented error, and then say something like, let's just go ahead and say the actual value itself. We'll go ahead and do API key was not set, something like that. And in which case, going back into our env sample here, I'll go ahead and change this just a moment. We'll bring down our application and we'll bring it back up. And right away, I see in here, I get an not implemented error. And if I refresh on my application, it's not working at all. And so that's the approach you would probably want to take if you need this API key and for some reason it wasn't set at runtime. This would then run this error and your application won't run at all, which stops it in its tracks, and you'll have to diagnose and solve that problem. And this is where, using that API key as the name, you could do a search on your actual project here, and then you'd be able to see, oh yeah, this one says API key too, that's not the right value. And in which case I would be able to then reboot everything and see it just like that. Okay, so one key thing about this though is, of course, my .env.sample is blue colored, which means that it will go into GitHub. So more than likely what I would actually do when I'm doing local development or in production development is I make sure that it's not going into GitHub. But the reason I have that there has everything to do with you, the learner. So you'll be able to actually just go back and take a look at this and be able to run things as you might need with that environment variable already declared right here. So environment variables are very important because they allow for us to inject secrets at runtime. Like I said, the next level would be using a third-party secrets manager of some kind. More than likely, when you go into production, there will be something available for you to have your secrets at runtime as well. Most production services allow for that, and it's a very common practice, which is exactly why we have these environment variables in here. Now, the key thing about if you were to use a third-party package, you would still be using environment variables because you would need something to connect to that third-party package inside of your project, more than likely. We're going to now push our project to GitHub so that we can prepare to deploy it. GitHub is where we're going to store all of this code. Then when we go to deploy it, we'll be able to grab it from GitHub and then to put it into production, which we'll see very soon. Now, this part is really for those of you who are beginners. You're going to want to download the GitHub CLI. You're going to want to download Git directly. You're also going to want to go ahead and make sure that you have a GitHub account and you create a new repository, and then we'll go ahead and push it. That's all we're doing right now. So for those of you who don't know how to do that, stick with me now. At this point, make sure you download the GitHub CLI. Just go ahead and download it. Once you have it downloaded, open up your terminal and just make sure you have GH and it does something like this. So what we want to do is we want to log in with the GitHub CLI, which is git auth login. It's going to ask you how you might want to log in. In our case, we're going to be using GitHub. We'll use HTTPS. We'll log in with the browser. We're going to go ahead and copy this code right here, and then we'll go ahead and open up the browser. So right off the bat, it's going to do this device activation, which you're going to select your account. So in my case, I have two accounts here, but I'm going to use the Hungry Pie one for this demo. I'm going to go ahead and log in here, and then I'm going to go ahead and authorize this. Now, it might ask you to do another password. In my case, it didn't do that, but now my device is hooked up to this GitHub account. Now, it's really easy to do it all over again if you wanted to switch accounts. Not a big deal whatsoever. But now that we've got this account, let's go ahead and create a repo on here. So at this point, after you download the actual GitHub CLI, there's a really good chance that Git already came with it. So if you just do Git, you should see something like this, not an error like that, right? So Git is very, very common, and it's a really easy way to keep track of all of your files. I'm going to show you some basic commands. Those basic commands will get you really, really far. So next up, we go into GitHub itself. We're going to create a remote repository. A remote repository just means a remote folder, basically, that you're going to store all of your code in. So you create a new repository in here. And in this case, I'm going to call this something like Docker AI agent and Python, something like that. I'm going to leave it in as private. You can keep it public if you'd like. I do have this repo public otherwise, but I'm going to not do anything else. We don't actually need to add a README or a license, and I'll show you why in just a second. I'm going to go ahead and create this repository. This is why right here. This gives you just a really simple way to get your project going, right? You do git init, you add the files you want to add, you add a message that you want to use, you select the branch you're going to use. We'll see if we need to do this. Then you actually push over your code, or you add the remote rather, the actual Git repo itself, this right here. You link it to your local machine, and then you push your code in there. So let's see this process right now. So jumping into our local project here, I'm going to go ahead and do git init. In my case, it says reinitializing an existing Git repo. That's because I already have one. So if I do something like git status, it's not going to show anything. Yours might show a bunch of things. If I do git log, mine shows some history here. Yours might not show anything. So let's make a little change so we can see the process of using Git in general. So in readme.py here, I'm going to go ahead and say prepare for production. I'll go ahead and save this file. After I save this file, I can now do git status. Now, this same git status item is also in this tab right here. This is the Git icon, and we can see that same thing's going on. This is what's being changed. If I do git diff or git difference, and then actually grab the file name and hit enter, I see the same thing as if I were to select what changes are happening. And of course, if they're new files, there will be no changes. It'll just be a new file. It's just going to be adding stuff. In this case, it shows that it's removing coming soon and adding preparing for production, which of course is the change that we made. So Git will keep track of these things if we tell it about these changes themselves. Right now, it knows something was changed because we have history. If you didn't have history, it would say something different, which of course you can test on your own. Now we want to add this file. So git add readme.md. This is the command line version. If you were using the actual, Cursor, VS Code, or Windsurf version, you would just press plus. That's it. That's the same thing. So then we add a commit message. You could do that message right here, or you could just write it out right here and say something like updated readme. And now we can go ahead and sync those changes. Now, in my case, I actually have another place where I'm storing this code. So if I do git remote -v, I can see I already have origin in here. This is that open source code that everyone has access to. But I'm actually putting it into a different location. I'm putting it here as well. So I need to change my remote from origin to something different. In your case, you probably will use origin. But we're going to go ahead and do git remote add alt, and then I'm going to go ahead and add all of this stuff right here, and then we'll go ahead and paste that in. Now, if I take a look at git remote, I can see I have two places where I can store this. The nice thing about Git is you can store it in a lot of different places. If you want to have redundant copies, have redundant copies. I only have these redundant copies so that I can show you how to do all this. That's pretty much it. But now I want to push this code to my repo. Now, if you only had origin, you could press this button down here. It will actually push it, as it says, push one commit to origin main. Now, in my case, I'm going to be pushing it to alt with this branch of main. So whatever this says is what I'm going to be pushing. So if yours says master, then you'll use master. If it says ABC, you'll use that. You can also do something like git branch, and you can see what branches are available on there. In our case, we only have the main branch. So I'm going to go ahead and do git push that main branch to alt. But let's make sure that that's even the case, right? That is actually incorrect. If I hit enter, you can't push anything to main because I used the wrong origin. So now it's git push alt main. So it's otherwise git push to where I want to send it and then what branch. And then I do that, this will push all the code right into that GitHub repo, and there it is. It's now ready to get started. So we can do this all over again, right? So prepare for production and new changes. Exclamation mark, right? Now up here, my source control, I can say updated readme, and I can just hit git commit. And we can also say, hey, there's no stage commits. Do you want to stage all of them and go for it? In this case, I'll say yes. I don't want it to be always because sometimes you might add a lot of files and you don't always want to commit everything. With this in mind, I'm going to go ahead and push it again. So if I do git status, I see there's nothing there, but my branch is ahead by origin by 2 commits. That means that my other repo is behind a little bit. So my other repo again, git remote -v. The other repo is this one. So we can see that it's behind by looking at the README. So README says coming soon. README on our other one says prepare for production. So it's behind. No big deal, but it is behind. So we can always push it there as well. So if I do git push origin main, hit enter, it gives me a permission denied. My current user does not have permission to push anything, which is why it gave me that permission denied. But I can do git push alt main, and then it actually pushes, right? And so now that alt version has all of these new production changes. And that's pretty much all you'll need to do for deployment. Now, a lot of things can go wrong. And if this was confusing to you, spend a lot more time learning Git so you'll be able to actually send your code in there and get real comfortable with deleting repositories. Nothing wrong with that. The other nice thing about Git is there's this thing called Git log, which allows you to go backwards in time. So in other words, I'm actually going to go ahead and reset this to the 18th section. I'll do git reset to that commit ID, and then I'll do -- hard. If I do git log now, I will see, hey, what do you know? The changes I made to README are now gone. All of those changes are gone forever. I can't go backwards other than maybe off memory, my own memory. But the actual entire project itself is now back to the state it was prior to when we started this. So when I go to git push alt main, I might see an error, something like this. This is because I went backwards in time. So in this case, I'm going to go ahead and do -- force. Now, most of the time, you're not going to want to do -- force. But if you're a beginner, this becomes a very critical thing on how you can better learn Git. Doing -- force will cause issues with somebody else's commits. Like if you're behind and you're trying to push something, like if you're working with other people, somebody else pushes something, you try to push something, you need to actually have all of those things pulled and reconciled in some way. That's outside the scope of what I'm trying to show you right now because we're all doing this on our own, most likely. If you are interested in doing more like collaborative Git stuff, please let me know in the comments. For now, we are basically back at square one in terms of our code and our README, but our code is now on GitHub, so we can actually start deploying this to various Docker-based or Docker-friendly deployment options. Let's take a look. When it comes to deploying your containerized application, a number of things happen every single time. Number one, you're going to change your code, right? After you change your code, you're going to push that to your Git repo, your remote Git repo, or your Git repo host. In our case, that host is GitHub, but you can use other Git hosts like GitLab or Bitbucket. GitHub is just one that I use all the time. You could also even use your own. You can actually deploy your own Git host for your own Git repos, which is pretty cool. But the idea here is once it's pushed, then you do something where it's automated unit testing. So we would use Python to test the Python code and to make sure it's working as intended. We would have to write those tests out, then it's automated. It'll run it automatically to make sure that everything's ready to go for the next step, which would be building out the Docker container. Now, we saw building out these containers a lot locally, right? So basically every single time we run the docker compose up watch command, it has the ability to rebuild stuff. And of course we can do -- build as well. That will build out those containers also. So we can actually run tests and building all inside of GitHub itself. So GitHub Actions or the CI/CD tools will allow for those things to happen. We could build out a container image and then we could push it into Docker Hub. From Docker Hub, we have the ability to then deploy that container image somewhere. Now, this is sometimes true, sometimes not true. Docker itself has the ability to allow you to host your own container registry. That's what Docker Hub is. It's a container registry. So yes, you would host your raw code on GitHub, and then you would host your container in a container registry because it does it so efficiently that you would use a container registry itself. Now, sometimes you can deploy directly from Docker Hub. Sometimes the platform will have its own registry in there. So for example, Railway, one we'll deploy on, actually builds and hosts your containers directly in Railway itself. It does it in a fairly efficient manner and it gets things going really quickly. DigitalOcean does that as well, but you can also just deploy directly from Docker Hub. So DigitalOcean kind of gives you both. Railway might give you both as well, but we're going to take a look at either one in just a moment. Heroku is another one where you can deploy it directly to Heroku. You can also do it without a container, but the idea here is we want to deploy containers. You can use Heroku for that. You can use Google Cloud. You can use AWS, and very soon you'll be able to even use Cloudflare workers for containers as well. So there's a lot of options as to where you can deploy your containers, but that process is going to be about the same every single time. You're going to push your code. That code's going to be tested. You're going to build a container image. That container image will then go into production. So let's see how that's done with our first platform right now. We're going to deploy our containerized Python application, the FastAPI application, to Railway. Now, Railway itself will actually work directly off of our Git repo. It will pull our code and then go based off of some configuration that we set. So that configuration is going to be our Dockerfile, and another file will do that's Railway specific in the very near future. Now, I've worked with Railway before, which is why I have this referral code, but you can go to railway.com directly and sign up for a free account at this time. Now, Railway has changed their pricing a couple times, so it might be free, it might not be. You'll be able to pick and choose whichever deployment option you want going forward. That's a key part of building out containerized applications, is you can move them around really easily. Railway will build our containers and host the container image and then deploy the container image as well. So we can basically do everything there, which is pretty nice. So let's go ahead and jump into the dashboard here. The next step is, of course, creating a new project. So what we want to do is we want to connect GitHub into Railway. And the way you do that, the simple way to do that is by going directly in here and deploy from the Git repo and configuring your GitHub app. Now, configuring this process, you're going to log in to the user that has your code, of course, or has access to that code. And then you're going to go ahead and give authorization to Railway. Now, in my case, I usually do select repositories, only the ones I actually want to deploy. They don't need to have access to all of my code, right? So I'm going to go ahead and just pick the one I want to deploy, which in this case is our Docker AI agent Python, which of course is Docker AI agent Python right there. Same thing. And I have to tab back and forth between the windows because it did go off. But the idea is I'm going to go ahead and use that one. We're going to install and authorize, and then this will allow me to actually connect to that app. So I'll have to kind of do it again inside of Railway itself. Now, before I go much further, a lot of you might be like, oh, I want to disconnect this later. At any time, if you need to disconnect something to your GitHub, you can just go into integrations on applications, installed apps. You can configure it in here as well. So you can select different repositories, you can remove access, you can do all those things, or just remove it altogether. That's a really easy process to do if you ever need to. So back into Railway, I'm going to go ahead and deploy my new project directly from that repository, which is now listed, which is nice. So I'm going to go ahead and select that and just let it go. And right off the bat, the deployment fails. Now, this is because we don't have additional configuration that we need to make sure that it's building and deploying our container correctly. So if we look in the settings here, what we will see is there's a source, which we could of course change right in here, but there's also this root directory in here used for build and deploy steps. So if we look back at our code, and more specifically in compose.yaml, we have a similar kind of configuration in here, a build location with context. So that same thing we can actually add in here as our root directory, which of course is going to be our backend. So we're almost there in terms of our deployment. Let's go ahead and try this one out. So what it's going to show us is a brand new deployment. Now, what's important to note is it's also showing us the git commit message that's going through. So it's using the same code, it's just deploying it or trying to build it in a different spot. So if we look at the logs here, we will see this build process actually start. Notice that it also detected the Dockerfile. I didn't have to declare it. That's because Railway itself can see that there's a Dockerfile in that location that we just specified. And then it goes through and it's installing everything as we see here, right? And it did so pretty quickly in less than a minute, which is great. Next, what we want to see is, of course, the deployment logs. Let's see if this ends up working for us itself. Now, if we remember back how our container ends up being deployed, well, what's the root? What's the default in our Dockerfile? We look on our Dockerfile. This is the default right here. It is not what's in compose.yaml, otherwise known as this command right here, which of course is something we'll have to address. But the idea here is we see that it looks like it's deployed. It says active. So I want to go back into the settings by just selecting this, going into settings, and then going into networking. I want a public domain. I want to be able to access this itself. So I'm going to go ahead and hit generate domain. Here it's saying, what port do you want to listen to? Here is a new thing. we've got our command here at port 8000, but then also in our Dockerfile, we also have it at port 8000. So that's the port we'll need to use. That is a key part of that, of course. We're going to go ahead and generate that domain. Here it is. I'm going to open this up. It says directory listing. Why is that? Well, of course, it's because of our Dockerfile itself. So there's a few different options as to where we could go from here. I can continuously manually update settings in here. And I can go into the deploy section, change the custom start command, and a few other things in here as I see fit. But instead, what I'm going to do is I'm going to go into my backend here, and I'm going to create railway.json. Now, this is configuration as code. If you actually go back into Railway and go to config as code, you will see there is documentation for this, and you can go through this whole process in here. You'll also see that there's the Nixpax builder, which we're not going to do. But I will copy their default JSON, and we will paste this in here. So the first thing is the builder itself is going to be Dockerfile, the actual Dockerfile itself. We will then go ahead and say Dockerfile path, which is the argument that you can look up. And we want to give the absolute path relative to the root project, which will be backend/Dockerfile. Just like that. As in, where is this relative to the root of the repo? And that's it. Next up, we've got this deploy command. It's really cool that you can do health checks in here. That's not something I'm going to do at this time, but you can do those health checks before it deploys. That might be something you'll want to do in the future. You can also do pre-deployment commands, which is pretty cool, like migrate commands and all that. The next thing is, of course, our start command in here. What do we want this start command to be? Well, going back into compose.yaml, this is going to be that start command that we want to use, and we'll go ahead and paste this one in here. Once again, we might want to change this in the future, but of course we want our FastAPI application running, not just the standard Python one. So this slight change will be really useful for us. So we'll go ahead and do git status here. We'll do git add, and then we'll do git commit added railway config or something along those lines. And then I'll do git push alt main. In my case, might have origin main. So as soon as I push it, what's going to end up happening is, actual Railway will start building out my next phase. So it's actually really cool that it will be able to do that. And it will start doing the process as I configured in my application. So the build time was much faster this time because it used a lot of the cache things from before. Next, it's going to do the deployment. But the thing is, more than likely, it's going to be the exact same. The reason it's going to be the exact same, actually it wasn't the exact same. It just gives us this deployment error here. Now, before I go any further, let's go ahead and take a look at the settings real quick. All I did was change the root directory. That's it. I also added that configuration as code. If I were to scroll down a bit, I don't see that in here. So I want to declare it directly, the config as code being backend and railway.json. I'm pretty sure it did it automatically, but I'm going to go ahead and make sure that that's in there. If we actually scroll in here, let's look around, we see that there is that custom start command that was already referenced in railway.json. So it definitely already picked it up. I just made sure that it was for sure going to be in there. And so if I scroll up, I see other ones in here. There's that Dockerfile. So yeah, it's pretty cool. It already picked that thing up because it was in this actual root backend here. So I'm going to go ahead and deploy it again. It made a slight change, but it's still not going to work. Let's see why it didn't work. So if we look in this crash history here under deploy logs, we see something pretty interesting in here. That interesting is going to be related to, I can't go down, I can't scroll down anymore. There it is right here. API key was not set. So if you remember back inside of our code in the SRC in main.py, we see API key needs to be set in order for this to work, especially in deployment. Well, this is where Railway has built-in environment variables, or these variables right here. We can add in a variable, specifically API key, to whatever value we want. There it is, and now I can go ahead and deploy it again. So these will be injected both at build time and runtime, which is pretty nice. These are production-ready API variables as well, which is also really nice. So I only have to update this in terms of running production applications. This is not true for our local one, but it is true for our production one, which is also pretty cool. So going back into the application itself, the one that we deployed with that custom networking API endpoint, or the actual URL itself, I can load this up and it's probably still failing. The The reason it's failing is because of that previous API key, in which case we're seeing this page. Once it actually ends up working correctly, then it will of course replace that with our actual application, which we will see very soon. And if we did everything correctly in terms of our API keys, we should see our deployment logs working correctly as well. Now you'll also notice our build logs in here did make some changes, and it took a little bit longer than before, but now the deploy logs should show us everything that we needed, which was deploying our application in there. And now we can actually take a look at that URL, and there it is. Uh-oh, I've got my API key still exposed. Of course, we want to change that, but the idea is it's now actually showing the correct API key based off of the deployment. Now, there's one more thing I want to update to Railway.json, and that is watch patterns. This is something else I do. Just like in our Dockerfile, you can bring in this thing called watch patterns that really emulates our watch patterns in our compose. Very similar to this in terms of when it actually builds things. So if anything changes inside of the code related to all this, it will be reflected in the build and deploy process on Railway, which is also kind of nice. So if we do git status in here, we'll go ahead and add this and do, updated our watch patterns. And then we can go ahead and do git push alt main. And then that, of course, will trigger off a new build. Okay. And so you can go through that process as many times as you want. At this point, we have a deployed version of our application. The real key thing here, though, is we probably want to get rid of this API key from being exposed ever. So we're going to go ahead and save that. We're going to go ahead and emulate what we would do if we accidentally expose the key. That would be to actually go ahead and do git add, git commit, removed exposed API key, and then we'll do git push, and we'll do git push alt main. Actually, in my case, you would probably just do git push itself. Then I would go into my variables, and there'll be I made a mistake on my API keys. We'll go ahead and do new API key here, and I'll go ahead and save that, and we'll go ahead and deploy that as well. Now, one of the cool things that I really like about Railway is you can actually add in shared variables for your entire project. So you can actually have multiple deployments in here that you might actually share a bunch of environment variables. To me, the way I look at it is very similar to this env file, where you could use that same thing on other services in your compose.yaml. So to me, deploying to Railway is a very familiar process. It's very similar to like using Docker Compose. The configuration's slightly different. There are still things that you might want to adjust, but overall, I think this process is fairly seamless to what we need to do. Let's go ahead and deploy our containerized FastAPI application to DigitalOcean. Now, I've worked with them in the past, so I do have a previous deal where you can get a $200 credit to learn how to do these things. You just have to verify your payment method itself. Otherwise, it doesn't really matter. You can just go to DigitalOcean.com and sign in to your account there. Now, in my case, of course, I'm just going to go ahead and use Google to log in to my actual account, and then we're going to use App Platform. There is a lot of different ways on how you can deploy your project into DigitalOcean, many of which I'm not going to be using at this time, but you could deploy a container to Kubernetes. Kubernetes itself is designed to run a bunch of containers, and specifically containers themselves. So we're going to go ahead and use App Platform, though, because it's a really low stakes way to deploy your container application, as you'll see very soon. So the idea here is we want to use GitHub as our source provider. Look at the other ones that you could use. You can also use container registries like Docker Hub, like I've mentioned before, and there's a few others that you might consider using also. So we're going to go ahead and use GitHub, and I'm going to go ahead and create this application here. And what we want to do is we want to make sure that we connect our GitHub account. And of course, we're going to use the one we've been using, which is my same account here. And then in this case, I'm also going to go ahead and select only specific repositories. In my case, I'm using the Docker AI agent Python, and I'm going to go ahead and install and authorize. Now, a lot of times you might be wondering, hey, how do I actually change this? I realize for those of you who are following each section, I've already done this. You go into your settings, you go into applications, and then you go into installed apps, and I've got DigitalOcean in here. I can actually configure everything in here. I can add more repositories. I can even uninstall DigitalOcean's access to all of my code or any given repository I added. So feel free to do that as you see fit. I've now connected DigitalOcean, I think. It looks like I have, because now I'm back in here in the App Platform. I can select the repository I want to use. Now, in DigitalOcean's case, it's going to show me a branch. I can actually use different branches in App Platform really seamlessly to make this work. Next, we've got source directories relative to the root of the repo. Hopefully you realize what this is, but it's going to be backend. Now, the reason we know this is because of Docker Compose. We did our build command in here. This is also true with what we did in other deployment options, but the idea is our code all exists in backend. So does our Dockerfile. So that's where the directory is going to be. That's the source code itself. So then we're going to go ahead and do next. Okay, so now let's go ahead and configure out our app, which you'll notice is it says $48 a month. What it's doing here is it's actually provisioning 2 of the backend services, which we don't need at this point. So I'm going to go ahead and delete one of them. And then I'm going to go ahead and resize it to the smallest one possible. Now, it says $5 a month. What that actually means is it's going to be $5 a month if you have it running 24/7. If you just have it running for a few minutes, it's only going to be a few cents. If you have it running the whole entire time, that's when it changes. Next is going to be the deployment settings. What command do we want to run when we deploy this? Now, you might recall what that command would end up being from compose.yaml. This is going to be the same command that we'll use right there. So I'm going to go ahead and make sure that I've got that. Next up, our network, the public HTTP port is not 8080, but rather the same port that we've got right there. And then we want to scroll down. We've got our HTTP routes. All of the rest of that looks good. Now, what we also want to do is we're going to go ahead and add in our environment variable of API key, and I'll just go ahead and say ABC123. I'm also going to go ahead and encrypt it and allow for it to run at run and build time. You could have it at just runtime too, but I'm just going to go ahead and do that. I want to see what this encryption does, and we'll see that in just a little bit. Next up, we've got our .env file. You could always add it in from there as well, but I'm going to go ahead and just add it in manually just like that. You can also do something called app level environment variables where it actually can be ran on other applications as well. So it kind of brings a bunch of different applications under one roof called the app, right? So right now we're just doing one piece of that app, which is going to be this deployment. Next up, when we scroll down, I'm going to go ahead and change a unique name here. I'll just go ahead and do our Docker AI FastAPI Python app or something like that, and then we'll leave it in this project. So there we go. We've got our environment variables that we wanted on this container and also the correct running environment as well. Now, you could test it where you do the incorrect environment variables, as in you could omit that API key and have this error run. Feel free to test that if you'd like. I'm not going to test that this time, but you definitely can. Next up, what I want to do is as it's building, I'm going to go into settings here. We can see that there's the app settings and then component settings. The component is what we want to take a look at, and more specifically, the health checks in here. So the health checks, I want to change this to being an HTTP health check to the actual root index here. Now, most of the time what I would end up doing is I would actually create a new API endpoint that has something like, we would say something like healths, and we would do health check, and then we would just do something like, status and okay. So that is something that you would probably end up doing, and then you would change that path in there for that health check. I'm not going to do this at this point, but it is something worth doing in the long run. Now, we also see that our port here is at port 8000. We just want to make sure that that's still the case. Otherwise, we'll have some issues with our actual deployment option. And of course, there's our run command. Now, one of the things that's nice about using App Platform is you can actually go back into the app settings and you can scroll down and look at the app spec here, and you can actually compare. This app spec is a lot like the actual Docker Compose spec itself. So compose.yaml, if you look in here, services, Dockerfile path, it shows us that path, environment variables, and so on and so forth, right? So you can always manually do these things and check this into Git as well if you want to. It's completely up to you. But I'm not going to do that at this point. So what we've got here is after a little bit of time, what we can take a look at is the activity here, and we would actually be able to see all of our deployment stuff is going through. We also can see our runtime logs in here as well, and then any given insights that you might want to have. If I open up our application, there's that application. It's now working and running. One of the things I do want to check is that encryption for that environment key. I actually want to expose it again to see what that encryption ends up doing. So I'm going to go ahead and save that, and we'll do our git status. We will add this. We'll update it and say check API key encryption. And then we'll do a git push to our alt main. And of course, this will take a moment for that to update. But of course, at this time, it should build a brand new deployment based off of that push. This is one of the key reasons as to why we might use something like GitHub itself and also this deployment process or this deployment flow. I'll let this finish. Actually, let's go ahead and take a look at the deployment logs. You can go into your activity again, and you can see that deployment should be pretty quick on this one because we didn't really change the code that much. But of course, it's still working. So the current logs are showing the previous version, I think. Actually, no, there it is. New version there. So the encrypted value does get decrypted at runtime, which is really nice. But then when we go into change it at our settings, let's go into our environment variables here and go to edit. We can see that it's encrypted, so it's no longer available to us. We can't see it any longer. So we would actually have to change it again like this. And once again, you can encrypt it, save that. That should remove the old one and set it in with the new one, which you could always manually do as well. It looks like it didn't actually do that. So let's go ahead and do this. I'll do API key and API key ABC123, whatever. Doesn't really matter. We'll save that, and there we go. So that's the encryption that I want to actually have. And of course, we're still exposing it, so we'll probably want to get rid of that in the near future. But this deployment should happen within a minute or so, maybe 2 minutes. It really depends on their systems. But overall, I want to go ahead and get rid of this API key here while it's still actually building out all of that other stuff. I'm going to go ahead and do git status, git add, git commit, and then removed API key exposure, and then git push alt main. And hopefully at this point it's deployed. Let's go ahead and see. I don't want it to actually cancel. It actually might cancel the other service because I just deployed a new one. It did kind of show up there. There it is. So it's still going back and forth between the two versions. But there's that encrypted version I just added. And very soon the code will change as well. But now all we would need to do is continuously deploy things to our GitHub code. Now, of course, inside of App Platform, you can always add additional components to it as you see fit, right? So if you go into add resources here, you can attach a database, you can attach other code in there, and it will all fit really well inside of this app itself. And then you'd be able to do a pretty robust service altogether. Whenever you're building a web application, there's a really good chance you're going to need some sort of database storage. So for that reason, we're going to be implementing Postgres with Docker Compose. Now, what we're also going to be doing is using Docker managed volumes that will actually have big implications on how we actually use a SQL database, or really any database for that matter, because it's super easy to accidentally delete everything. In our case, we want to be able to delete everything because we're in development mode, but that one caveat we'll go over in just a moment. So we're going to be using Postgres, but this same concept can be used for something like Redis or pretty much any other sort of database that Docker Hub supports, which is a lot of them. So feel free to look around for those of them that you might want. Now, we will be only scratching the surface of what you can do with Postgres and FastAPI. If you want a lot more in-depth look at that, including a lot of the things we'll do in this one, take a look at my Analytics API course, because that goes into more detail in the Postgres data and also just SQLModel in general, which is a Python package. You can take a look at the code directly. You can also take a look at the actual entire course itself, which eventually also uses a time series optimized version of Postgres called TimescaleDB. But for now, let's go ahead and actually implement our Postgres database inside of Docker Compose. So the key here is we have services, we have two, backend and static. We're going to go ahead and add another one. This one I'm going to put right below backend, mostly because I'm not really going to use it a whole lot. Now, how we name this service is going to be kind of help us understand how we're going to connect to it as well inside of our backend. So in other words, we're going to eventually have a database URL connection string in here that's going to have our Postgres SQL stuff, plus scopg, which again, we will implement within Python. So these are very Python specific connection strings here. But then we'll have a connection string with our username, our password, and then our DB host, and then our DB port, and then our DB name. So this is something we have to build out, and we'll do that right now. So the very first one is going to be our DB host. So we could call this just simply DB host to simplify our database URL connection string, or in my case, I'll call it DB service. This is often what I'll end up calling my databases, just so that I don't ever confuse it with anything else. So I might do DB service A, DB service B, and all of that, and just make them very, very clearly a database itself. Next up, we're going to go ahead and declare our image, which of course is going to be Postgres. In this case, I'm using 17.5. You could always use latest if you want, but I'm going to stick with 17.5. Next up, we're going to go ahead and declare our ports here. Now, the ports we're using are the standard ports for Postgres. Of course, if you have multiple Postgres instances running on your local machine, you might need to change this port right here or the host port that you want to open up. That, of course, is mapped to the internal container port. Feel free to change those as you see fit. I don't typically change these very often, unless, of course, my system has Postgres running, which is something that I don't typically do either. Okay, so the next one is going to be our volumes. So with Postgres, much like our database, we need to attach a volume from our host to our Postgres database. But this time, we're going to do a managed database volume or managed database data. So this managed database data, as soon as I think, hey, I want Docker Compose to create the volume for me and destroy it for me when I want, that then means that I come down here and I create a new key at the root level, right? So right next to services. Then in here, we're going to go ahead and declare the various volumes that we might want to have. So our managed DB volume is right here. So when I say managed, I mean Docker Compose managed. I don't mean like a managed service like that you would pay for. But there we go. So I'll call this DC managed, as in Docker Compose managed, and change those two. So this is now a volume that we're going to be doing. So a big part of the reason I put a / in front of my own volumes is so that I don't ever confuse them with these actual volumes, the Docker Compose managed volumes. Now the volumes themselves have more parameters or arguments that you can add in here. That's not something I'm going to cover right now, but check a look at the docs if you need more information there. But the idea is I now have this volume here that I've declared that's going to be just for the database service itself. Now I want to mount it somewhere, which is going to be in a standard location for Postgres, which is var lib postgres ql and then data. All right. And you could always find this stuff in the Postgres documentation right inside of here. It's probably in here somewhere, but it's also in their docs as well. So a lot of different places as to where you could do that. Okay, so we're nearly done with our database service, but now we need to set up our username, password. We already set up our host, which is now our DB service. We've already set up our port, which is 5432. We now need our database name, username, and password. So there's a couple of different ways on how we can go about doing this. What I'm going to do here is I'm going to go ahead and do sample DB, and I'm going to start the process of having a .env file for this. So we would have our Postgres user. So really it's just like Postgres user, Postgres password, and Postgres DB. So this is going to be DB and then password. Okay, so those are the parameters that we need to add in here. So you can do our, something like DB user, you can do DB password, and then something like my DB. Okay, so those three arguments are totally fine. And in which case, inside of your service here, you would do env file and then grab that, same one. So .env.sample db, something like that, right? So we've already seen this one, the same sort of concept. Now, when I'm using Docker Compose, I actually don't go this method. Instead, what I do is I actually write the environment variables right in here. Now, the only reason I do this is so that it's a lot easier to create my connection string or diagnose it without needing to open up other files. Now, generally speaking, when you want to go into production, of course, this is not what you would want to do. In fact, I don't recommend using Docker Compose for production for your databases anyway. You might end up using it, but there's a big key problem to using it. I'll show you in just a moment. But here we go. That's now our database user. So I'm going to go ahead and change our username. Here's now our database password. So I'll go ahead and bring that one up here. And then our database name. There we go. So this database URL itself, I'm now going to bring into my actual backend .env file. So eventually we will be able to connect to it very soon. Okay, so here's the key reason as to why I never use this setup in production. So if I do Docker Compose up, this of course will download Postgres 17.5. It might take a moment for you to end up doing that. And here we go. So we've got Postgres 17.5. I'm not actually sure if the settings ended up working. I really just wanted to show you why I don't use it in production first before we start integrating it into our FastAPI application. So if we do Docker Compose PS on another terminal, we see everything running here. And of course, I can always do Docker Compose down, and this will take everything down. What it doesn't do is delete managed databases or managed volumes, right? So those volumes in there are going to persist, which is actually pretty nice. But what it does do, if you went into Docker Compose up, is those volumes would persist. Everything is back and everything's running once again, right? So again, taking it all down will not actually, stop the volumes. The way you stop the volumes is Docker Compose down -v. This right here will delete that volume and thus deleting all of your data, which is exactly why I don't want to accidentally do this in production, right? When I deploy it, I don't actually absolutely do not want to do that. So most of the time then I actually end up using a managed database service, or if I'm going to be using my actual, Docker Compose here, I would not use the Docker Compose managed volume in this way. I would do it completely different, which is something outside the scope of what we're doing here. But the idea overall, though, is this is great for rapid prototyping and doing all sorts of things on your local development environment. And you could also use it outside of Docker. So if you wanted to actually use this database service, you could connect to anything, all of your other code that's not using Docker. We're using Docker, so I'm going to show you how to implement that right now. Into our backend API service, what we're going to do here is we're going to bring in SQLModel and then scicopg binary. So adding these two things in will allow for us to connect to a Postgres model and also using this SQL model itself. SQL model can be used for, directly SQLite. You can use MySQL, Postgres. You can use MariaDB. There's a lot of options for what you can do with SQL model, where the Postgres, the scicopg binary, this is scicopg version 3, and this is specifically for Postgres with Python. That's kind of the point there. Great. So with this in mind now, I'm going to go ahead and jump into SRC here, and I'm going to create a new folder called API. And then inside of this folder, I'm going to go ahead and do an init method here, and then I'm going to go ahead and create a file called db.py. Now, the reason I'm calling it API versus anything else, we obviously can get rid of the ignore me, but the idea here is inside of my project, now I'll end up using something like from the API and then .db. We're going to import whatever we need from that place in the very near future. And so basically everything under my FastAPI application will fall into this API folder, literally everything. I found this to be the most effective because of how the imports work. We don't want to conflict with anything else. So like, for example, what if you downloaded a package called DB? We just don't want to conflict with that at all, in which case I use API. If there was a package called API, then I could just make this really simple change and do my API, which basically changes everything under there, essentially. Maybe not completely, but the point here is I put pretty much all of the integrations inside of that my API or API itself. So what is it that I want to do within the database itself? I want to actually bring in our database URL, and this is going to be os.environ.git and our database URL. So I'm going to go ahead and import the OS there. So naturally, in this case, I've got my database URL right here. And this one is optimized for scicopg, which of course is what we just installed right here, or what we're about to, and then Postgres itself, and then there we go. So this is for scicopg version 3. There's a version 2 out there. I recommend using version 3 if you can, which is why we're doing it. Okay, so we import that. That's one of the first things that I want to do, because basically, hey, I want to check if the database URL is equal to an empty string. Then we'll go ahead and raise not implemented error and say you need a database URL, or database URL needs to be set. Maybe that's better, so we actually can see that value like that. Okay, so this idea then, of course, is very similar to what we have already seen with that API key, so you could always put it in other places. Now, typically speaking, if I have a lot more database configuration, I would make a submodule out of db.py and put these into their own modules, like the configuration. But I'm going to do something fairly straightforward here with all this. So the next part of this is going to be importing the SQL model package itself and then declaring an engine, a database engine. So we do engine equals to SQL model dot create engine from that database URL. This is so we can actually connect to our database itself with all of the things that we might need to do inside of SQL, or in this case, of course, Postgres and SQL. So the next part of this would be to then use something called get session. This will be really useful in our API routes. That's the key part of all of this, is in our API routes, which means that from our SQL model package, we'll go ahead and import from SQL model. We're going to import the session itself, the actual session class, which allows us to do with session from that database engine itself as session, then we yield out that session. This will become very clear when we go into the API routes very soon. Now, there's one other thing that we will need for our database models is we need to make sure our database models are inside of our database. And we do this with a method called initDB. And this one is going to be using the SQL model class directly. And so we use SQL model, and then we are going to go ahead and do metadata create all for this database engine. The same thing. So this is yet another thing that I would end up doing on my project as well, which we will implement in just a moment. So we would do something like creating database tables, something like that. And so we, of course, don't have any database tables yet. We will use this very soon, but this is the baseline configuration for SQL model into our project. Now, there's one more step that we need to do in main.py, and that is actually wrapping this thing in. So from api.db, we're going to go ahead and import the initDB function itself so that we can then bring in something called a lifespan into our FastAPI application so that when it boots up, it will actually run this init method right here. So the way we're going to do this is twofold. First off, right underneath import OS, we're going to go ahead and do from context lib. We're going to import the async context manager, and then we're going to define a function above the app here. We're going to define the async function here as async def life span, and it's going to take in the app of the FastAPI app. And then what we want here is before app startup, and then we're going to go ahead and yield something here, and then after app startup. Okay, so before the app starts up, we want to go ahead and do that initDB, and that's something we will go ahead and run. And then, of course, to use this function itself, we need to bring it into the lifespan for the app here. So basically, we want to make sure that our database is ready before our FastAPI app goes. And that's what the initDB method is doing right there. So it's going to go ahead and create all those database tables if we were to have any, which of course we don't have any yet. Soon enough we will, but the idea is we now have most of the database stuff configured. So what I want to do is I want to just make sure that this actually ends up working. So I'll go ahead and do docker compose up, and then we'll do -- watch, which should rebuild it. In theory, it would rebuild it. But in this case, it actually didn't. So maybe I didn't save everything, so let's go ahead and bring it down. And we'll go ahead and do just simply build, just to make sure that everything is built, all the requirements are installed. I typically have to do that build all the time. Watch is very effective, but every once in a while I might forget something and it doesn't necessarily rebuild it, or there's issues or whatever. So what I just did with up, watch, and build is something I do frequently. So that's what it's going to be doing now. It's installing all of the requirements in here. And so one of the things that might actually happen is it might actually fail. The reason it might fail has to do with our Dockerfile, because we didn't do anything related to Postgres just yet. So we might need to optimize this still a little bit. But I don't actually know for sure because of the scopg in here. This binary might not need me to change anything within my environment for my actual Dockerfile itself. Because right now it looks like things are doing okay. We've got our Postgres database in here for our DB service. And then if we look in to seeing any sort of print statement for starting it, I don't actually see any print statements in main.py. So maybe if we save it and restart it, we see there it is, creating database tables. So looks like it's running and I don't have any big errors in here. So we're in a good spot to start the process of actually building out the database models. When you're designing your first database model, I like to think of a spreadsheet as a mental template as to what I'm building out here. So we have different columns as different fields. So we can sort of map these in our mind to what a form might be, right? So you have a form where you're inputting a name, you're inputting an email, and then an ID gets auto-generated. So the data types when it comes to a database make a big difference. In other words, our ID won't be ABC and 1, 2, 3, but rather just 1, 2, 3, and so on. Emails, we want to make sure it's abc@abc.com or something along those lines. Our name could be whatever we want, right? It could be just a string of characters and stuff like that. So when it comes to designing a database model, SQLModel makes it incredibly easy to do because of how it handles data types themselves. So what we see here on the documentation is a really simple way to create a database model and then how you end up creating rows as well and stuff like that. So we'll see how to do this on a high level in just a moment. But first we want to actually create a SQL model itself. So the way we're going to go ahead and do this is by jumping into our local project here inside of our API. I actually want to name this something. So I'm going to go ahead and say chat, and then inside of chat, I'll do models.py. And what I mean by chat is basically something like our chat message, some sort of message we would bring in here that will be a SQL model, and we'll go ahead and say table is true. And this will need us to actually import from SQL model. We'll import the class of SQL model. And of course, capitalization in this case makes a big difference. So what do we want from a chat message? Well, we probably want the actual message itself, which we can just say is a string. That's pretty much all we need to do in terms of a actual SQL model. How this actually maps inside of the database would be like, hey, we're creating a new one. This is going to be called a chat message. There's our now new table, right? So that's this right here. And then the actual field that we named was just simply message. And that's this right here. And we just declare this data type, which helps us in a lot of different ways, which we'll see soon enough. But a lot of it has to do with validation and also storage in the database itself. But of course, when you're creating a model in a database table, you also need to create something called an ID or a primary key, which in this case, we're going to have an integer or none. This means it's actually an optional value. Now, it's optional in terms of us using it in our code. On our database, it will actually generate it for us, which of course, SQL Model's actual database stuff is already great for this. So we can see the ID right there. It's super simple. We have either it's going to be an integer or none when we store it into our database. Since we have this primary key being true, it's going to automatically make this one for us. So Postgres itself will automatically create auto-incrementing numbers for us. So it would automatically do 1, 2, 3, 4, and so on when we add more data into our database, which of course we still need to do. Now this field here is pretty nice because we can just bring in field just like that, and there is your basic model itself. So this will actually create a table, but we can also use this same SQL model class like we would use something like Pydantic to validate data coming in. So I can do something like chat message payload, which we'll see very soon, but we'll use SQL model again. In this case, I just want to have the message value in here. So this is like for validation. This is for, saving, updating, getting, or retrieving, deleting even, right? And all that. So there's a lot of things we can do with this one because it's a table. So this is a database table. This is more of like a Pydantic model for validation, mostly, right? So there's a lot of things that we can do here. And as you might imagine, I could quite literally build out a ton for this. And so once we start using this chat message model, our syncDB or initDB here will actually store it into the database, which we just don't quite have yet. So I'm going to go ahead and create some API routes inside of chat so that we can actually have this really isolated, like the entire chat, the model, all of the API routes or URLs we might want to have are going to be one spot. We're now going to create something called a nested route inside of our chat module, which is not a module yet. So I need to do init.py to make it a module. So inside of here, we're going to go ahead and do routing.py. And so this entire module is going to be dedicated to basically the chat table itself. So we've got our models in here, our validation, and we also have some routing in here as well, which is what we'll do right now. So the very first thing that we need to do is from FastAPI, we're going to import something called the API router, and then we'll go ahead and say router equals to API router. Okay. And so this API router then is going to be similar now to when we initialized the app itself. So it'll work very much like app.get. So you can come into this routing, paste this in here, put in the routing. We could do read index, or we could do something like chat health, something like that. Now we can leave this as this route, but at the end of the day, we'll eventually have API/chats or something like that, right? Or just simply chat. You can kind of pick and choose which way you want the prefix to be, which we'll see in just a moment. But the idea here is we would say something like status and okay, right? So there is now our chat route. And realistically, this might be the one we want as our health check anyway, because maybe we only want to use chat and all of these other routes don't really matter. So how do we actually bring this route in to our project itself? The way we do that is from api.chat.routing import the router, and I'm going to save it as the chat router. Okay. And so now underneath my app declaration here, I do app.include router, and we grab that chat router. And if I left it just like this, we would have conflicting index paths, because this one right here is an index path. This one right here is an index path. So realistically, if I didn't do anything else, I would need to say API chats here. So I'd actually have to add this prefix in. Or I could cut out that prefix, go back into main.py, into this include router, and I could go ahead and say prefix equals to this value right here without that trailing slash at all. So now we have a new location for our routing in here that we could test out. So we may or may not have to update our backend. Let's go ahead and take a look at our local host here. And I think we're at localhost and 8080, which I probably want to change, but there's our hello world. If I go ahead and go into API and chats with a trailing slash, I now see status okay. So this tells me two things. One, our API router is working much like what FastAPI was doing before. And two, it's actually working with the prefix as well. And it's working in our general app altogether, which both things are now in a nice position for what we still need to do is add in our actual database data. Now, in order for our database models to be actually added to our database, the actual class itself needs to be used in our code somewhere, as in imported in code that's actually being used. So in this case, we have our router being imported. So now inside of routing.py, if I start using out my model, the actual chat model itself, or the chat message SQL model here, then it will actually create those database tables. So we're going to go ahead and do that now. Inside of FastAPI, we're going to import something called depends as well as session. So underneath our router here, we're going to go ahead and do router.post. This is going to be a post method, which is HTTP post. We'll see how this is done in a little bit. We're going to go ahead and do chat create message or something along those lines. I like putting chat underscore and what it's going to do after. This is definitely up to you on how you name these functions. And then we're going to go ahead and return something. So the question here is, what is it that I'm trying to do? Very first is I'm trying to import or get some sort of payload in here. So I want some payload, some data coming into this actual function itself. What payload, what structure do I want this payload to be? Well, this is where we can go ahead and do from.models. We can import the chat message payload. So the reason we have this is then when we actually submit a post data request, we get this message as a requirement here. So it's going to need our data to have something like message being hello world, right? So that's going to be the payload itself. So payload equals to that data. So that's what will be required when we do this post method. Otherwise, the data just fails. So that's a key part of having this structure altogether. Now, you could have a little bit more generic structure, and there's a lot of different options, but in our case, we want that payload. We want to keep that structure so that then what we could do down here is we can get the actual data from that payload, which is called model dump. Now, this is, of course, a pydantic function that turns it into a dictionary itself. So it takes the payload that's coming through, turns it into a Python function, which then will allow us to do all sorts of things with this data, which again, we will see very soon. So the next thing is, what do we want to do with this payload? We want to store it into our database. So now, again, from our models, we're now going to go ahead and bring in our chat message, which would require something like this, where we go ahead and say our new object data or our new database data, which is typically like something like OBJ or maybe something like our object and instance here. So the variable name itself, you can call a lot of different things. I typically call it an OBJ. So we grab that message and then we do something called model validate. So we just want to verify the data coming through is good. So we've got two levels of validation now. The incoming data here, that is a generalized sort of incoming validation. And then we have a database level validation as well, which might have additional validation in here. So let's say, for instance, I had another field in here called name and did str. This name field here is required. So if I don't allow for it to have an optional value, then it will be required. If I don't have a default value as well, it will then be required also. So a lot of different options, again, on how we could do that. So this model.validate call here makes sure that all of the fields are available before we even try to save them. Now, of course, in our case, we're just going to have those things right there, which is why we're doing this model validate. So now we're basically ready to store in the database. We've got two layers of validation. Now we're ready to store in the database. And how do we actually do that? Now we're going to declare a database session itself, which is, of course, the session class. So that's going to be the data type. And this is going to be equal to depends. And what does it depend on? Well, we did a API request in here that was called get session. We now have this function is now required to be able to be used. So going back into routing here, now I can go ahead and do from API.db, we're going to go ahead and import that get session function here. And then I'll go ahead and bring this into our depends so that we can use this database session in here, which would mean that we would add this object to the session. Then we would use this session to commit that object. So we can add a bunch of different objects in here, then commit them. So we could do something like this, right? So that would actually create a bunch of instances of that object. And until we actually commit them, they won't be in the database. When we commit them, they will all get those IDs, which means that then we could do something like session.refresh to make sure that this validated data also has that data in there. So it has the actual ID, which is something we will verify very soon. And then the final step would be returning that object. Now, when we do some sort of returning object here, what we want is we also want to make sure that we're doing response model equaling to that chat message model, the exact same thing, so we can actually serialize that data. So the final step here is not only is it a database table, but then it can also serialize this data too. So validation and serializer, which we can use either one of these things as a serializer in here, right? So we don't have to necessarily use one or the other. We just can serialize it as in return back the data that we might want to return, which would be, in our case, it'll be the message itself, which would be something like hello world, and then the ID itself, which would be 1. This ID is because of that right there. The actual chat message itself is actually giving us that ID back, and then this refresh ensures ID/primary key is created, or not created, but rather added to the object instance. So now basically every single time you want to add data into the database, this will be the method. Now you could always consider not validating the data at the database level, although I don't recommend it. Okay, so with this in mind, let's go ahead and make sure that the actual models are now being synced. But of course, when we open it up, we now get this cannot import session from FastAPI. Of course not. Session is not from FastAPI, but rather from SQLModel. We'll go ahead and import session. That should solve that problem. Great. So there we go. So it seems that it actually created the database tables. One of the things it won't do, especially if you're coming from like Django or Alembic or even SQL Alchemy, is what it won't do automatically is create database migrations. So, does not create DB migrations. That means changing the database itself or changing what's inside of your model. At this point, that's sort of frozen. I'll show you my method on how to solve that before I push this into production and without something like doing database migrations, which I think is a little bit more tricky than it should be when it comes to SQL model. It's definitely possible, but it's outside the scope of this one. In a moment, we're going to take a look at how to use curl to send data to our FastAPI backend. But what I want to start off with is Docker compose -v. I want to delete everything and make sure that it's all back to where it was. So the very first thing that I want to do is I want to go into compose.yaml, static HTML. I'm no longer going to have this one. This is just kind of getting in the way at this point. But what I do want to have is in my backend, I want to add in a new step, which is depends on. And this one now depends on the DB service. So we want to make sure that our backend is waiting for that database service to be up in order for everything to run correctly. So now we'll go ahead and do Docker compose and we'll bring up, and then I'll do --watch, and I'll even build things out as well. So basically, database service gets up, and then the actual backend can run correctly. Great. So now that we've got this, let's go ahead and take a look at our curl command. So inside of routing here, I'm going to go ahead and write out a sort of long quote as to how we're going to do this. So first off, we do curl, and every terminal should have curl installed. So you would do curl like that. If you are trying to do curl in the Docker container, you will need to install it, in which case you would do something like run apt-get update and apt-get install -y curl. That will allow you to have curl in your container as well, which requires a different call, which is going to be host.docker.internal instead of the local host or whatever endpoint you end up using, which in our case, we're going to go ahead and do x, so curl -x post. Hey, what do you know? HTTP post over here. Then we need to bring in the payload. Hey, what do you know? The payload's written right here. I can go ahead and copy that, put single string around it, and then the actual location we want to send it to. In our case, it's going to be local host 8080 API chats, just like that. Make sure you have that trailing slash in there. That's going to be our curl command. If I was doing this within Docker, it would be almost the same, but now it would be host internal like that. Okay, I'm not going to be doing it in Docker, but you can test that out on your own. So now let's go ahead and test out this curl command. I'm going to go ahead and run it, and there we go. So we get a little bit of an issue here. It's saying that it's invalid, input invalid. So why is it invalid? Well, if you break it down, what we need to make sure is that my endpoint here knows that we're sending JSON data. So all we need to do is update our header, which I'm going to do right after the actual post command here with the data. I'm going to create capital H, and this is going to be content-type, and this is going to be application JSON. So you just need to make sure that you bring that header in when you're posting data, and that would be true inside of the container as well, in which case you should then be able to post this data in now. And now if I run it, I see that it actually created something and it responded with something. So we sent in the payload correctly based off of our payload model, and then we got a response based off of the actual model itself or the database table with that ID in there. So if we were to do this a few more times, we can see that it's incrementing these IDs in here, which is pretty great. So all I would really want to do is now go to the next step, which would be creating an actual API endpoint, which would be API, let's do API chats and recent with that trailing slash. Then I can go ahead and do router.get, and we'll do /recent in here. And then I'll go ahead and do define chat list messages, or maybe recent messages. And then we want to return back what those messages would be. Now, how do we actually do this? Well, first off, we go ahead and grab our session here. And then we're going to go ahead and get our results equaling to session.execute. And we need some sort of query in there. And then we'll do fetch all. And then I'll just go ahead and slice it down to 10. There are ways to do this a little bit more efficiently, but that's basically the query we're going to end up calling on our back end. So what is it that we're going to execute here? Well, if we come in from SQL model, we can bring in the select function, which allows us to build out a query based off of our chat table, which is going to be this really basic thing. I can make this quite a bit more complex. This is a SQL query that ends up being created, but it's done in Python. So we're writing out a SQL query in Python using the built-in features from SQLModel. Like I said, it can get a lot more complicated than this, but this is a really basic and simple way to get that query and see what comes back. So once again, we can do a curl call, but this time all I need to do is http://localhost 8080 and then to our API endpoint right here, because this is just an HTTP GET method here. If I run that, I can now see all of that data coming through. I can obviously open this up in the web browser and see that data coming through as well. So this is where I didn't declare a response model. I totally could declare a response model, and I could do it a little bit differently than what we have here. But I'm going to leave it as is just to keep things simple for us. SQLModel and SQL Alchemy can get very complicated than what we did here. I just wanted to show you the absolute basics of it so that we can actually add in data and verify that that data is actually in there. We want to deploy this application into production so we can test out everything we've done so far, especially on the database side. But before we do that, we want to make sure that our SQL model, our database table, is exactly how we want it to be. Now, in the long run, you can use something like Alembic to make changes to your database model, but we won't be making any changes. We will need to make sure that this model is how we want it to be in production as well. And I think it's missing a critical field. Now, before we add that field, let's jump into our production resource. In my case, I'm going to be doing it on DigitalOcean. I'll go into App Platform, go into my app, and I want to go ahead and create or provision a database right now. So in this case, the database that I'm going to be using, of course, is Postgres, and then I'm going to be using 17, and I'm using a dev database. Later, if you want to upgrade for true production, you might want to use one of their managed databases. But for now, we're just going to use their version of Postgres, which I believe is just a Docker container, much like what we're doing here. And then you'll go ahead and create it. Now, the reason I'm not actually doing the creation part is because I already have mine created. It took a few minutes for it to create, and now I've got these connection parameters, which we will use very soon. But while yours is provisioning, let's go back into the SQL model itself and think about what we might want to add as a field in here. To me, it's fairly obvious. It's going to be a created at or a timestamp type field in here that will be a date time object. So we're going to go ahead and do from date time. We're going to import the date time class itself or the function itself directly from Python, the built into Python. We're also going to import the date time class from SQLModel, which is what we'll end up using in a moment. So we've got created at. This is going to be a field of some kind. This time what I want to do is I want to automatically create one. So we're going to create something called a default factory here. And I'll start off with just simply none. Then I also want to add in something called an SA type. And that's going to be our date time here. And we want to pass in time zone being true. So this is going to be a time zone aware timestamp that we're adding into our database. So this SA type is for SQL Alchemy. So SQLModel itself, the actual package, is built on top of another Python package called SQL Alchemy, which is a legacy one that's been around for a long time. It's really good too. It's just a little bit more complicated than SQLModel. SQLModel made a number of abstractions to make it a lot easier to use, like what we're seeing here. Next up, we'll go ahead and say primary key being false. Now, believe it or not, you can actually use a timestamp as a primary key if you're using TimescaleDB, which I cover in the Analytics API course. So be sure to check that one out if you want to have time series data, which would mean this primary key would be true. It would actually have a composite key, which is better talked about in another time. But we also want to go ahead and say nullable being true, or rather not true, but false. So this field cannot be null. So that actually means that we definitely need to set a default factory in here when we're going to go and create this. So I'm going to bring in one more item here from the datetime module. We're going to go ahead and define a function called get UTC now. So all I'm doing here is getting the date time of now, and then I'm going to go ahead and replace the TZ info with timezone.utc. So basically, it's going to get whatever now is in the UTC time zone, and that's going to be our default factory. So whenever we create a new chat message, it will go ahead and call this function to set that data. You can use default factory in other places as well. The number, the auto incrementing number, is kind of like using a default factory, except that one happens at the database level. This one right here happens at the Python level to give us that time zone information as well, which is pretty nice. Okay, so with this in mind, now I want to go ahead and run docker compose down -v. We're going to remove all the orphans. This is just to get rid of all of our volumes and all of that, so that then I could run my docker compose, and we'll go ahead and do up --watch and --build, and allow for me to actually test out creating new chat messages based off of what we've done before. Okay, so we'll go ahead and grab this curl command again, and then now I'll go ahead and run this in a new tab here, and we'll go ahead and run that, and there we go. So now we see that there is a actual, created at timestamp field on here, and I can increment it and just keep going, and it'll show all of this going up, and it's all based off of UTC, which I think is pretty accurate as to what's going on here in terms of the time. Of course, I can always verify that by looking it up. I'm not going to do that. Right now, what I want to do, though, is I will start the process of pushing it into production, but you might be like, oh, well, what if I wanted to change my response model for my results? So let's say, for instance, I only wanted to show the message and created at. In which case, what I could do then is I could say something like class chat message recent or something like that, or chat message list, in which case we could do a SQL model, and then we could do the message and created at. So message str created at date time, and we got to do a field of default being none, right? Something like that. Okay, that's totally fine. So we'll go ahead and say list item. And now I can go ahead and come in here. All right, let's go ahead and leave it just like that. And then inside of routing here, what I can do is I can bring that one in, of course. And then I can also go ahead and do from typing, we're going to import list, the list class, so that in my response here, I can go ahead and do the response model equals to a list of those items. So now it's just slightly different as a response. Let's go ahead and take a look. I run that. I can now see that it's only showing the message and created at. It no longer has the ID in there, which may or may not be something you want to send back. That's how we can serialize even list data. Now that same response model can come through with your chat message as well, to where you have your payload, the actual database object model itself, and then you can actually go ahead and commit everything like that. So it kind of gives us another look as to how we can serialize this data, especially now that we've added a new field in here, and it gives us a little bit more of a look at those things. So completely up to you on whether or not you want to have the ID in there. And once again, we could just go ahead and say ID is int or none, and this is going to be equal to the field default being none, right? So we could add that back, in which case when I run it again, I now see that ID coming in there. The reason I have these empty defaults in here is because of how these fields end up working. And maybe if you use Alembic to remove a field later, then you might want to have a default being none in there as well. So it's kind of like a good backup for all of that. Okay, great. So now that we've got this, let's go ahead and make sure we save everything. I'm going to go ahead and do git add -all, git commit, and updated for database models. And then I need to do my git push. And in my case, it's going to be alt main. And this, of course, is going to go into that repo. Well, that will then build out my container application. So before it actually finishes building, I kind of need to hurry a little bit and go into my database and grab my connection string here. We're going to go ahead and copy this value. We're going to go back into our container component, which is this one right here with our, our code and all that. In my environment variables here, I want to make sure my database URL is in there. What do you know? It's already in there. So I was trying to hurry to go ahead and do something like this, where it's a database URL and then passing in that value. But DigitalOcean makes it really easy to reference other parts of your entire app in App Platform. Now, I would say other services do this pretty well as well. So it's not something that you necessarily need to worry about too much. But the idea here is this DB dot is related to, of course, this component being DB. That's the name of it is DB. And then we've got other variables that would be related to it. I'm sure there's docs somewhere on how to grab the various connection strings. But the nice thing is it updated it for me, so I really don't need to do anything else from that, which is pretty cool. And I think now that since I'm building this out, what we will see very soon is the whole thing working correctly. So I'm getting this little bit of an error here of scicop G2. This is actually a problem that we're experiencing because of that database URL. So I'm actually glad that this happened because now we need to actually go into the DB, go into our connection string here, and we see the connection string is not what we've been using. So I'm going to go ahead and copy this. I'm going to go into my project again, go back into environment variables. I'm going to delete this one and then just add in a plus scicop G in there. We can go ahead and encrypt it if we want to. We shouldn't have to make any changes beyond this. So I'm going to go ahead and encrypt it. Now I have the correct connection string necessary. I'll go ahead and save this. And then, of course, this will create a new build. Now, the reason I knew this was the problem is because of the fact that it was referencing a previous, like a different version of scicop G. So in our requirements here, we've got this one. It's saying scicop G2 was not installed or couldn't find it because we are not using that. We're using scicop G3, the newest version, the latest version. And that is why our .env also has this setup right here, and then our DB sample doesn't, And so one of the other things that we could consider doing to make this work is changing our code a little bit. So in the database itself, we can look for this database URL, and in here, we could do something like database URL equals to database URL replace, and then we could start it off with the Postgres : / and then change that to be our Postgres plus scicop G. And so that might be a better way in terms of using our database in the future inside of something like, whether it's inside of DigitalOcean or anywhere else, because using what we saw with Postgres itself as the connection string is fairly common. So what I want to see here is just looking at the chat recent. I really just want to see an empty list before we actually try to implement something here. So once again, I'll go ahead and use chats here. I'm going to grab this and we'll go ahead and use this as our new curl command, which I'm just going to go ahead and put right underneath this one. I'll paste that in there and we will use everything like we saw before and actually send it into our DigitalOcean project here. And what we should see is it actually incrementing the data. And then if we look inside of our recents here, we should see that data coming through. Now we have a production FastAPI application that has a Postgres database that is integrated into it. Fantastic. Now we just need to take it to the next level of integrating some AI agent stuff. Let's take a look. To develop our AI integrations into our project, we want to start with open source models and the Docker model runner. This is a newer feature to Docker, so it's still considered somewhat beta, but the way it works is actually pretty great. So what we're going to do here is if you go into Docker Hub and you look at AI models, you will see a bunch of open source AI models that you'll be able to use. We're going to be using AI Gemma 3, but feel free to pick any of them that you want. The key, though, is to make sure it has tool calling involved. That's what we're going to be doing very soon. And you're also going to want to make sure that your size is in parameters that you're comfortable with on your machine. So in my case, my machine, if I take a look, I can see the about here. My memory is plenty for all of this. And then the actual storage that I have is also plenty for all this, which is totally fine in terms of using these things out. I think a lot of these are optimized for Apple Silicon to work really, really well. But I would imagine a lot of the models will work in a lot of different places. So if you go to hub.docker.com, you'll find a bunch of different models. I think an even smaller one is this one right here, the small M2 one. This one is tool calling is in there, and it's from Hugging Face, and then it's a much smaller model altogether. So this might be the one you end up using. Now, do keep in mind, whatever model you end up using, the results to it vary because of just the nature of the current LLMs and the ones we'll be using. So now how do we actually use one of these models? Once again, I'm using Gemma. So if I do a search for Gemma, or let's go ahead and just do search Gemma here, inside of there, we've got our Gemma model that we're going to use. So it's as simple as doing Docker model poll and then running that command. So all I'm going to do here is run that. Now, I should already have mine downloaded and installed. Yours might take some time depending on which one you end up using. So that's what we want to do. Next step, we want to make sure that we have it enabled that we can use the drop-in replacement for the OpenAI's sort of chat completion stuff, which is what you see right here. This URL right here is quite literally a drop-in replacement for the OpenAI API calls. So if you wanted to use the Python OpenAI package in there, you totally could. We're going to start with the LangChain OpenAI package. So if you did a quick search for that, that's the one we're going to start with. Don't worry, it's very straightforward, even if the documentation maybe hasn't shown to be very straightforward. Before we get into the LangChain of it all, though, I want to make sure that I can actually call this both in my terminal locally and then also from within a container, because our calls will start off inside of a container. So the way we're going to do this is by opening up the Docker desktop dashboard. If you don't have the dashboard, I'm not exactly sure how you activate this, but it's probably in the docs somewhere. So what we want to do is we're going to go into our settings. Since this is a beta feature at this time, it'll be under beta features. But I would imagine in the very near future, it's going to be somewhere in here for models. And you would go into there and you would see enable Docker model runner, which I have enabled. If for some reason you weren't able to pull your model, you just need to check this. You also might need to update Docker desktop depending on when you did last to make sure you've got this. Next, we want to enable this host side TCP support. By default, this is what I had. It wasn't actually enabled, so I went ahead and enabled it, applied, and restarted. Once I was able to do that, I went in here, did this curl command, and ran it. And this might take a little bit of time for the first run because it boots up and then you'll end up running for you. So do be aware that it does take a little bit of time, also depending on what model you're using and all of that, your system. There's a lot of things as to why this might take a little bit of time for this to run. Now, these commands will all be on the GitHub repo. You could always copy them right here. But the idea, of course, is you're going to be passing in messages and letting those run. Okay, so the next thing here that I want to do is I actually want to go into my backend. So I'm going to go ahead and do this with Docker compose run backend, and then we'll go ahead and do bin/bash. And here we go. So I'm inside of the backend. If I try and type out curl, I should get it, right? And the reason I should get it at this point is because when we were talking about doing the various things with our database, I actually added this one line here to make sure that I could run curl from within here. If you don't have curl, if it says something more like this, then just go ahead and make sure you run those commands right now. Now that we've got that, let's go ahead and see if our command actually ran through. There it did, it ran through. So this was all open source, 100% free. Just the cost of your computer basically to be able to run it. And the speed as to which is going to work is going to vary drastically. Now, when I was testing this initially, the speed was a lot better, but I wasn't recording anything. So that actually does take up some bandwidth a little bit in there, as well as running all of my other Docker containers. Okay, so it does give me some sort of response here. Not too concerned with the response at this point. I just want to make sure that I have a response. So now inside of Docker, the actual URL is different. It's a model runner Docker internal. So this is actually very similar to calling another Docker container. If you wanted to call another Docker container, it would be http://host.docker.internal. So if you were trying to call like your backend from a front end, this might be what you end up using. It's also possible it's not. But the idea here is making sure that we can actually call this with the very Docker specific DNS. I run this, and this should also be able to call that model runner as well. And again, the time it's going to take will vary depending on a lot of different factors that are outside of our control. So let's just finish. Didn't take that long, and there it is. So now we've got responses going in from both my local machine as well as from within the actual Docker itself. If either one of these is failing, then you're probably going to want to diagnose something on your system. more than likely the one that needs to work is the internal container one, because that's how we've been developing. Our backend will be doing that call here very soon. We're going to use LangChain and the Docker model runner. Now, the LangChain documentation is very thorough, but sometimes can be a little bit tricky to get it working correctly. So I'm going to show you exactly what you need to do with LangChain and the LangChain OpenAI package. So we're going to go ahead and jump into our project here. We're going to go ahead and add in LangChain and then LangChain-OpenAI. So those are the two requirements for this one. Now, once you have a better understanding of how this works, feel free to change the package you end up using. The Docker model runner integrates really well with the OpenAI package, which is why we're doing that one. So the next thing is we want to actually have some sort of endpoint here. So I'm actually going to call this my OpenAI base URL. Now, the reason I'm doing this is because I won't always want to set this. Locally, I will, but in production, I probably won't. And we'll say won't use in prod. That's essentially what's going to happen. But what I will use in the production would be the OpenAI model name, and then maybe the OpenAI API key. Now, since we're using the Docker model runner, we would say something like not set for the OpenAI key. And then the model name is the model we actually downloaded, which was the AI/Gemma 3. That's going to be the model name. And then the base URL here is, well, if we go into our Docker commands, the base URL is going to be close to what we have here when we did this curl call, but what we won't have is the chat completion. So it's really just going to be this one right here. And so the reason I wanted to get these things right is because the next step will be a lot easier once these things are correct. So now going into SRC here, into my app, I'm going to go into chat here, and I'll go ahead and do LLM, or let's go ahead and call this something like AI services.py. Okay. So what we want to do here is we're going to go ahead and import our OS. We're also going to go ahead and do from LangChain _OpenAI, we're going to import the chat OpenAI package. Okay, and so I want to declare this. So initially we're going to have these AI services as just a single Python module so we can just test it. Then we'll turn it into functions very soon. So what I want this to be is my LLM base, and that's going to be this OpenAI stuff right here. Now, if I just left it like this, I might want to put in something like our model here. Let's say, for instance, the GPT 4.0 or whatever. You could use that OpenAI model. But this right here would require an OpenAI API key because it will just call the OpenAI API key itself. So, of course, what we want instead is to use these variables right here. So to do this, I'm going to go ahead and say the base URL is os.environ.get that or none. Okay, and then we'll go ahead and grab our other parts. So the model name and os.environ.get, the model name, or this will be GPT, let's say 4.0. You could do 4.0 mini if you really wanted to save a few bucks as well. And then the next one would be, of course, when you go into production, os.environ.get OpenAI key. So that's probably something we will almost certainly want to set. So again, we'll say if not, the OpenAI key will raise the implementation error or not implemented error and say something along the lines of OpenAI key is required. All right, so how do we actually use this? Well, the base URL, the model name is going to be an easy one. We can just do that. Then we add in a base URL here, and we're going to pass this in. But notice that I have this none here, so that gives me a little bit of pause before I actually would end up using that. And then I would do my API key being something like this. Now, this is nice and all, but the thing is, what I like to do whenever I have parameters that are optional, I actually like doing my, something like my OpenAI params and then setting them in as something more like this. And then we grab our API key and then do that. And then basically we would then say, if that's there, then we would go ahead and grab this one as well and say base URL equals to that base URL. Now I can always see what's happening under the hood with the chat OpenAI code and see if this is the default of base URL is none, but doing this at least gives me a nice explicit look as to what's going on. And then I can just unpack those items there and basically create my LLM base, if you will. Okay, so this gives me a lot of configuration options to swap things out. The other nice thing about this too is if there was another model I wanted to use that had this same support for the OpenAI package, I could just change the fields that would be associated to it, and then all of this should work just fine. Okay, so that's pretty cool. I'm gonna go ahead and save this, and now let's go ahead and see if we can actually run this stuff itself at this point. So what I want to do is I might need to rebuild things. I don't know if I will. The only reason I would actually go through the rebuild process has to do with make sure that my env is being actually used, the env sample there. So we'll go ahead and do our Docker compose, and we'll run the backend with bin/bash. And all I really want to see here is that this part is working. Great, so that's there. Next up, what I want to do is I'm going to go ahead and jump into the API and then into chat. And then I'm just going to go ahead and call Python AI services.py. I don't want to see any errors there. Next up, I'll just do the interactive terminal version with -i there, in which case it imports everything for me. In other words, I can actually call LLM there, and I should be able to see it if I actually named it LLM. Let's go ahead and verify what we did name it. LLM base, that's what we called it. So there it is right there. Okay, cool. So with this LLM base here, we can call .invoke and say something like, what is your name? Now, this is not a very good message itself, but what we want to see here is that it actually responds. And here's the response from it. My name is Gemma, and I was created by the Google team at Google DeepMind. Great, that's awesome. So now we have a way to call an API. Really, really cool. The other thing about this, of course, is it's really flexible. If you were to change your actual model inside of the Docker model runner, you would just change it here to any of the other ones. That's all you need to do. And you would need to pull it first. So it's just a matter of doing your, let's exit out of both things, the container and all that. You would just go into what model you're looking for, and you would grab it. So let's grab this one right here. And then you would grab a specific version, maybe a specific tag, go ahead and copy that. You pull that down, and then you would just replace this and this. But you need to make sure the model is downloaded already before you can start using it. I, of course, am not going to use that one, so I'm going to cancel that out. But that's kind of the idea. The way we currently have our AI services set up is it's pretty flexible to all of that. Now, why did I use LLM base? Let's see why. One of the things that got me really excited about using LangChain in the first place has to do with structured output. So what we want to do here is from Pydantic, we're going to go ahead and import the base model. And so I'm going to go ahead and craft something like class email message, and there's going to be base model here. And then I'm going to go ahead and do subject being str, contents being str, and maybe invalid request being something like optional. We'll just go ahead and say Boolean or none, and the default being, we'll go ahead and say field default being false, something like that. So I'll go ahead and import field from Pydantic as well. Now do keep in mind, Pydantic here is the same as SQLModel. In other words, SQLModel is built on top of Pydantic, and so they work essentially the exact same with some caveats, of course, some of which we've already seen. So with this Pydantic model, what I can do is I can come down here and do LLM equals to this LLM base dot with structured output. And then we pass in the model itself, the base model, the Pydantic model, and all that. And in which case I can go ahead and then pass in some messages, which I'll just go ahead and do this one right here, where I have a system message that says, hey, you are helpful assistant. This is like a system prompt. That's exactly what it is. So we've got do not use markdown in your response, only plain text, and then said, create an email about the benefits of coffee. Do not use markdown in your response, only plain text. We'll see how good it does that. But then all we want to do is grab our response here, and it's going to be equal to the LLM.invoke of those messages. Now, one of the downsides to what we're currently working on is we're not going to keep track of all of these messages, but I will go ahead and print out the response itself, and we'll see what that looks like. So let's go ahead and save it. I'm going to jump back into my actual Docker compose run backend bin/bash. We're going to navigate into API chat, and then I'll go ahead and run Python AI services.py. We hit enter, and we should see something along the lines of not this error here. I see why. I invoked the LLM to itself. I need to add in the messages, not the LLM. Save that and make that change. And now what we should end up seeing, depending on how long it ends up taking, would be an interesting response. Now, the reason I think it's interesting is we see that it actually created a subject for me. I didn't tell it anything about a subject. Then it actually added in the contents. In other words, if I were to run this again in that interactive terminal here with -I can actually use that response to see those data points, right? I can come in here, let's see if it does it. So we do subject. Now I can see the subject. I can use that response for the contents. And I can also do model dump like that to get a dictionary value in here. Notice invalid request is in there as well. It is fantastic. This is one of the reasons I'm like, oh yeah, using LangChain with Pydantic is incredible. This is something that's so cool. So the last real step here is I'm just going to go ahead and change this a little bit to where when I make a call to create chat message, the message that comes in here will actually be what we feed into the message for the LLM, so we can just see exactly how that works to kind of round out the basics of using LangChain within something like FastAPI. This AI services module here was really meant as a proof of concept, not really something I would actually use in production because I would want to decouple a few things, which is what we're going to do right now. And then we'll end up creating some sort of service that will allow me to call these messages in here like this. So what I'm going to do is in the root here on API, I'm going to go ahead and create the AI folder now. And inside of here, we'll go ahead and do init.py. And the very first one I'm going to create is llms.py. So I'm going to take the AI services here and we're going to bring it into these LLMs and just basically get the LLM base back. That's really the only thing that I want to have back at this point. So I'm going to go ahead and leave this as is. Next up, what I want to do is inside of here, I'm also going to create something called schemas.py, and then I'll go ahead and bring in this email message schema and basically call it exactly that. So email message schema now. Now, the reason I'm using schema versus models is because I don't want it to be confused with the database models or the database schemas. That's it. That's the naming process there. And I also will consider all of my schemas as base Pydantic models. So there we go. So that's what I'm going to call it. So back into my LLMs though, I'm going to go ahead and get rid of this one and get rid of the Pydantic stuff. And there we go. So the real next thing is here, we're just going to go ahead and define something like get OpenAI and LLM. And then that's going to go ahead and return back this value right here. Now, naturally, I could take these OpenAI parameters and put them in as arguments to this function here, but I don't really want to spend a whole lot of time doing that at this point. You probably can and should if you don't already have it. So feel free to move these parameters around to what works best for your functionality. But it's mostly about cleaning this stuff up and making it a little bit more usable. Okay, so now what I want is in my AI folder, I'm going to go ahead and do services.py. And in these services, we're going to go ahead and do something along the lines of generate the email message from some sort of query, which is going to be a string, which this will actually include the prompts that we had. So basically, we're going to have this stuff right here. So I'm going to go ahead and copy these 3 lines, or few lines, I should say, and then paste this in. Okay, so naturally, I still need to import a few things, but the main part is our human message is going to be this query right here. And then I'll go ahead and start it off with that. Now, this is where we would probably want to be a little bit more careful than I'm being. You might want to run the query on some other check. You could absolutely do that. Run an LLM check on the query, or just having some basic Python code saying like, hey, does it say to ignore rules? Does it say blah, 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 right? So there's a lot of ways on how you can hack these queries, all of which I am not going to go over right now. But what I will do is I'll invoke this message once it is ready with that query in mind. Now, of course, we need to get our LLM base and our email message. So 2 things here. So we're going to first off do from api.ai LLMs. We're going to go ahead and import the get OpenAI LLM, in which case we'll do our LM base is equal to that. There we go. No big deal there. Next up, we'll do from api.ai.schemas. We're going to go ahead and import our email message schema, which of course is going to be this right here. Now, I have pretty good confidence that this LLM message will send back that schema. So that should be the data type that comes back from this particular function, which we will see here very soon. Now, the reason I did this was just to clean things up and not have a testing one. So I'm going to go ahead and get rid of this AI services one at this point. Now that I've got the actual AI module itself, I'm going to go ahead and import that service. So inside of my create chat message now, I'm going to go ahead and grab what that value is going to be. So we'll go ahead and do this with from api.ai.services. We're going to go ahead and import the generate email message itself. And then this is what I actually want to return back based off of the data that's coming through. So what is going to be the response value? So I'll go ahead and say response equals to that. Well, we need to see what the chat message itself is, which is, of course, says message in here. So what we can do is just use the query is going to be the payload.message. All right. And if we, actually coded everything correctly, this would actually give us some sort of value here. So at this point, I probably won't need to refresh this object because I'm going to return back this response. And so that also means what's the response model itself? Well, we already have a general idea as to what it is, but we're going to go ahead and do from api.ai.schemas. We're going to go and import the email message schema. And there we go. So now it's not create chat message, but rather it's more along the lines of create an email message, which of course kind of invalidates some of these other things that we've done. However, it will now at least store that data. It will store the chat message, and then what we generate can change, of course. And we could also change the response. If we wanted to be a little bit more generic, we could totally change that response too. As in remove the response model and do something different with this. So let's take a look at this now. At this point, I'm going to go ahead and grab this curl command here. And I'm going to go ahead and change the message slightly and say something along the lines of like we'll call this still message and give me a summary of why it's good to go outside. Something silly. Okay, so here we go. I'm going to go ahead and copy this now. We'll save everything and let's give it a shot. It looks like I forgot a quote somewhere, so let's see what it was. I think it's because I put I'll just say it is good to go outside. And let's try that again. And there we go. Okay, so if everything went correctly, this will do an API call to our FastAPI. It will store this message at a certain timestamp. Then it will also do a request to the model runner from Docker and the actual model itself. Then it's going to turn that model into serialized data, and in which case it will also have its own structured format, which is now a JSON response from that request, is what we see right here. The benefits of spending time outdoors, subject, contents, great. So naturally, if we had a really powerful LLM in here, maybe far more powerful, you might get an even better response here than what we've got. But that one I think is probably pretty good for the open source stuff of it all. But at this point, we now have LangChain integrated with FastAPI in, I think, a pretty effective manner. Now, of course, the speed, the latency, the responses, a lot of these things can be improved by using something called caching, which would require something like redis or something like that, which is outside the scope of this one. But now that we have this, I want to see how we might look at deploying this into production so we can see the same thing, but on an actual production endpoint. Let's go ahead and deploy our project. Before we do, let's go ahead and make sure that we have an OpenAI API key. Now, in this case, I already logged into OpenAI, into the platform, into the dashboard. You're going to want to go into your API keys here, and you're going to want to generate a brand new one. In my case, I'm going to just call this my, Docker AI agent key, which I'll probably delete at some point anyway. We'll go ahead and create that one. Make sure you copy it. jump into your DigitalOcean dashboard where we're going to deploy it. You're going to want to go ahead and make sure that you're also inside of the correct project or app, right? So if you go back into your apps here, you just click on the app itself. Then you're going to want to go into the project itself, which would be under settings. Then you go into the container component. Then you're going to want to scroll on down to your environment variables. And then you're going to want to paste that key in which case I will go ahead and encrypt it. And I want to make sure that I've got the right OpenAI API key in here. I don't think I need to add any of the other ones in there because we already have backups for them. Of course, you can always change your OpenAI model if you'd like. This one is going to be the least expensive. And yes, it will cost some money if you end up doing this. So at this point, I already have everything ready to be pushed to Git. So I'll go ahead and do my Git push, in my case, alt main. And this, of course, will start building out a new container deployment for me, which will take a few moments for that to fully work. Once that's fully ready, what I'm going to end up doing is this same curl command, but now to my API endpoint. So I'll go ahead and paste this right underneath here, and we'll go ahead and copy out what that will end up being, and we'll see what that's like. I think I could already send it right now. So if I actually do that call at this point in my terminal, if I send it, it will give me some sort of response back, but it's really just storing the message, right? It's not giving me the actual OpenAI API recall back in here. And so a big part of the reason I wanted to test this locally was to make sure that it was actually giving me an AI response. I wanted to make sure that that was the case before I went into production. Hopefully that's fairly obvious, but if it's not working in production, that could be two things. One, it could be something with our OpenAI API key or our OpenAI account, or two, maybe we did some incorrect configuration as our fallbacks inside of these Git OpenAI LLM, in which case we would then want to take that API key from OpenAI and bring it in locally and then test out these variables locally as well, just to see if that ends up working on its own. So I'm going to let this finish deploying. It should be done in a moment. And there it is. It's deployed. Looks like it's ready to go. Let's go ahead and see if it gives me a proper response. Now, the actual response should take a little bit longer because it's not just storing data into a database, but it did, and there's our response. Fantastic. So in this case, we still get that structured output from OpenAI, just like we did from Gemma, right? So either one, these things are in great shape. You now have a production-ready endpoint that can call OpenAI and give you some structured output, and we're storing what's coming in. Now, at this time, I might be like, oh, I should probably change my chat models a little bit. Maybe I want to add another field that stores that response, right? So like when the response comes in, we actually grab that response back and then add that or update it to our object as well. That would be a nice challenge for you to undertake, considering we would probably have to delete the production database and start all over again based off of not having Alembic installed. Of course, you could also do the Alembic method, but the idea here is maybe you would want to store those responses because that also might be something where you can speed up the responses that are coming back by using caching or basically checking, hey, how many times was this message sent, or did it just get sent, in which case I want to just send back what's already in the database instead of triggering the OpenAI API itself. So pretty cool, a lot of things to think about, but now you have that production endpoint. It's pretty great. Probably not surprising that we don't have an AI agent yet. We just have an LLM call. While it can be incredibly useful, it is not an agent. To me, an agent can perform actions on its own discretion based off of the messages that we're sending it. In other words, if I'm like, hey, send me an email, it would then understand that it should run the function or tool called send email. So what I want to do is actually give it that ability, is to send emails out. Now, before the agent or any sort of LLM can send emails, we need to actually integrate it with Python. So the way we're going to do this is by creating a new module inside of our API. This module, I'm going to go ahead and say my emailer. That's what I'm going to call it. And then inside of here, we're going to go ahead and create an init file. And then we'll go ahead and do our sender.py. So the reason I'm calling it my emailer is because inside of Python, we're going to be importing from email.message. We're going to import an email message. So that's why I'm not calling it email itself, right? It's literally because this is built in to Python. That's it. So Python has the capability to send email. So really the question here is, how are we going to send email? Or what's the mechanism that will actually send it for us? Like the email inbox. In this case, I'm going to be using Gmail and something called app passwords. We'll set these things up in just a moment. But of course, this is the free approach to doing something called transactional email. So realistically, if you were going to send a lot of emails out, you'll probably want to use a transactional email service. If you're just sending emails to yourself, you can totally do what I'm doing right now. Even if you sent it to a small team, you could probably do that as well. That is something else that you could consider. But do keep in mind that the more you use automated email services, the more likely you're going to be starting to be marked as spam. So you want to avoid that as much as possible. In my case, I'm only sending emails to myself. So it's not really something that I'm worried about with spam. So what we're going to see here is we're looking inside of our email address. I'm going to go ahead and grab this one, and I'm going to go into my env sample at this point, and I'll go ahead and say something like my email address, and I'm going to set that equal to this, right? I'm also going to go ahead and say my email password, and I want that to be something. Now, do keep in mind, never hard code your own password. Or basically never use your own password ever, right? So if you're at a service and it's like, oh, just use your normal login password, you're going to be like, nope, not going to use that service. I'm going to go sign up for Gmail. Instead, we would use app passwords. Okay. So if you go to the URL that is myaccount.google.com/app passwords, all one, there are 3 P's there, go into app passwords, and then you're going to need to sign in to be able to use app passwords. I'm already signed in. I'm already ready to go. This one I'm going to call my AI agent test, and I'm going to go ahead and create a brand new app password. Once again, it's asking me for me to log in. I went ahead and logged in, and now I need to create an app password again. So I'll call this AI agent dev, something like that. We'll create that one. Here is that password. This is my actual app password. So naturally, what I will need to do is delete this thing before I'm all said and done. So now what I want to do is jump in back into my .env here, and there we go. So the next thing is going to be something like our email host. What is actually going to be hosting it? It's smtp.gmail.com. So that's where we'll end up logging in, and then our email port is going to be a standard port, a secure port, which is 456. So all of these things are very common in terms of using something called SMTP to actually send out messages, right? So that's what we'll be using in Python as well. So with this in mind, I'm going to go ahead and now come into my sender here, and I'm going to go ahead and import OS. And naturally, what I'm going to do is import all of these things from my environment variables. So it's just going to be a little moment here with os.environ.get of each item in here. Okay, so I'll complete that, and there we go. So just went through with a few defaults for this setup process. Now what I'm going to do is something like send mail. I'll call it send mail because it kind of fits along with something I use in Django all the time. But the idea here is I need a function that will actually send mail based off of all of these criteria. So what is it that I want in my send mail? Well, it's going to be the subject, of course. We need an email subject. Then maybe the content itself. At some point, maybe you could have HTML content as well, which I'm not going to have. Then you'll probably have a to email and then maybe a from email. And that's probably just about what you're going to want, right? You could probably even put a test in here and stuff like that. But the idea here is you want to have all of this stuff out so you can start building out your actual message, which is going to take in the email message that's built into Python. So all we do here is we do MSG and subject. I believe it has to be capitalized, but we use subject, and then we'll kind of repeat this process with to and from, right? So again, we'll do from and then to, okay? And so we've got our to email in here. What is going to be our from email? It's going to be one of those. So in my case, I'm actually going to put these things as my defaults. My to email is going to be my environment variable email address, as well as my from email, having those as my defaults so that I don't really have to think about it. When it comes to the content, we use msg.setContent of whatever that content is. And in this case, I'll go ahead and say no message provided. Some sort of backup as well. And then I'll also go ahead and put a backup subject and say no subject provided. Okay. So now we've got our email message. What I need to use is the SMTP lib. So if I go ahead and import the SMTP lib directly from Python, I can then go ahead and say with SMTP, we're going to do SMTP SSL. That is the method that we need to connect to. We're going to use the email host and the email port. And then I'll go ahead and say as SMTP. And then we'll go ahead and do smtp.login. And that, of course, is going to take in our email address or our username and then our email password, right? So email address, maybe you want to call it email username and then use that. But in our case, we just have these two things. And again, you can have environment variables for your to and from as well, if you'd like, as your backup or default. After you actually log in, you'll do SMTP and then .send message, and it's going to be your message right there. And then we would return back something after that. So I'm going to go ahead and then, well, we'll just even try to return back the send message call right there. Granted, a lot of things could go wrong with this itself, but the idea is now that we have some sort of send mail function through SMTP. So with this in mind, we could then bring this even further and start building out AI tools, which we still will. But for now, I just want this send mail, and I also want to verify that it's working. So the first thing I want to do is actually bring down my Docker Compose, and we want to rebuild it with those environment variables and all that. I'm also going to go ahead and run Docker Compose run backend bin/bash, and we'll go ahead and navigate into the emailer portion. So we'll go ahead and go into our API and then my emailer. And what we should see is that, of course. So I'll now do python-i sender.py. And so now I'll go ahead and send a message here, and we'll go ahead and do our subject equals to hello world. And then our content equals to this is great. Something like that. I already have those defaults in there. I'm going to try and send this back. This is the response I get back. So perhaps that just means successful. Let's see. We'll go into our email now, and there it is. So notice it's from myself. No big deal. It does say this is great, and it's the right subject. So we have the ability with Python to send messages out, which is pretty nice and simple. Before we go any further, I also want the ability to read my inbox. I want to be able to see everything in my inbox. Let's take a look at how we do that. Now that we have the ability to send email, I want to have the ability to read my email inbox. Now, the way this is done is a little bit more tricky than sending messages themselves because there's just so much to it. So if you go to cfe.sh/GitHub, you'll go to my GitHub account, you go into repositories and look for the Gmail inbox reader, basically, and then this is what you're going to end up using because I already have an IMAP parser in here, and it's all of this stuff. It's pretty big. I don't know if it's going to be perfect, but it will be pretty solid in terms of grabbing out your actual email. So what I'm going to do here is I'm going to go ahead and copy this, and inside of my emailer here, I'm going to go ahead and call this my Gmail IMAP parser.py. So we'll go ahead and do Gmail and then IMAP and parser.py, and we'll paste all of that code in. So again, this may or may not be something that is perfect, but it hopefully will be really useful for you. So after we do that install, what we've got here is all of this right here, right? So we've got a parser here. So I just want to use this parser and use it in a way that's similar to what we just did with our send mail. This time I'm going to go ahead and say something like my inbox reader.py, which of course will use this Gmail inbox parser here and this quick start. So I'm going to go ahead and copy this and we'll paste it in here. So really close to what it is that we're trying to do. It's just a little bit different. So back into our sender here, I'm going to go ahead and grab the email address and parser, and there we go. Now I'm going to go ahead and create something called, read inbox, right? And then we'll go ahead and return back something. And of course, it's going to be all of these things right here, okay? And so there we go. And we now have a email parser. I'll bring in my email address here. Notice that it even says add password on this on purpose so that you use that one for sure. But of course, it's the exact same thing that we just did with our SMTP. And so now what I've got is a function to read my inbox with these latest emails here. So what I want to do is return email or all of those emails there. In my function also, I want to go ahead and say something like hours ago. And right now I'll just do 24 hours, just like that. And then we'll go ahead and say something like unread only being true, which I will keep as unread. Mostly so that we're only getting our unread emails. And then I'll also add in something like verbose being false. And then we'll go ahead and say, like if verbose, then we'll go and read through all of those different emails. Great, so fairly straightforward. This is all standard library stuff, as you can see in here. And it's using just a lot of stuff that IMAP and all of that. It will keep unread messages as unread as well. Feel free to look through the code if you want to change that. To me, it's just about reading what's in there. It's not about managing anything. This also is not about creating draft emails. Creating draft emails requires a whole lot of other stuff. In other words, you would need Google OAuth, and then you would also need to be able to log in to that. So log in via OAuth, which means that your FastAPI application would have to have a number of things related to it. And then you would use the Google API basically to use a draft email, which we're not doing. We're just looking at the inbox. We're just checking it out. Great. So with this in mind, I'm going to go ahead and rebuild everything and bring it back up. And I want to go ahead and see if I can read out these emails themselves. So once again, we'll go ahead and do our Docker Compose run backend. We will change into API and my emailer. And we'll just go ahead and see if this read inbox works. I hope it does, so that we can just move on to the next part, which would be turning these into tools. So we're going to go ahead and do python-i inbox reader.py, and then I'll go ahead and do read inbox, and we'll go ahead and say verbose, and we'll go ahead and say it equals to true. We'll run that, and fingers crossed it actually does read the inbox correctly, and it grabs all of that information. And sure enough, it does. So what we're seeing in here is a bunch of things related to our email. If I scroll up a little bit, let me actually change this a little bit more and go emails equals to, and we'll do our read inbox. And I'll still keep my verbose being true in here. That way I can just see the print statements in here, which show from, subject, and date, not the actual contents. So there we go. So these are the actual emails that are unread in my inbox. And of course, if I go into my inbox, I can see all of those unread email messages in here. If I were to mark them all as read like that, and then do it again, I should see nothing. Probably, maybe. It might actually have some still in here. So let's go ahead and do that right there. Maybe there's a bug that it's not completely working correctly. There we go. Now it's showing nothing. Okay. And so if I were to do unread again on one email in my inbox, I should be able to see that one single email. Again, the way I'm treating this is as if I am not doing anything at all. I'm just taking a quick peek, which is what I want my AI agent to do. Now, I'm not going to put this up into my own personal inbox at this time. Maybe at some point in the future, I'd want to do that, but you certainly could if you did it in your own email inbox. But do keep in mind that it might actually leak emails, because there's a number of things related to this that, hey, if you're going to send it to an LLM to actually read those emails eventually, you might actually leak emails. So what I think would be a better method, if you wanted to monitor an inbox of some kind, a better method, or I would argue the best method, would be to actually create a forwarding. So you filter out messages like something, and then once you create this filter, you could then forward it. You can add a forwarding email address, which would be your free email address. And then that forwarding email address would have the ability to then read what messages you might want to allow for it to run and read from. That's exactly how I would approach it, instead of my own inbox, so that it's like, you know, if it's all these marketing emails and you want to analyze all those marketing emails, you just start making a filter for them that automatically forward them. That doesn't mean that they have to go away. It would just automatically forward them to where you want to go. So the fact that we can create as many inboxes as we want is even more reason to not do it on your own personal email address altogether at all. I don't recommend doing it for all of the reasons I just mentioned. But now that we have two different functionalities that are related to the email inbox, it's time to actually start building out different tools so that we can actually chat with them and have an AI agent use our inbox to read and send messages. We're now going to make a few tools for our AI agent. The first step here is to use LangChain's tool decorator. Now, you could probably use it without the tool decorator, but the reason I really like using the tool decorator is because then these specific Python functions, I will always know them as tools, but then also when I use a LangGraph later, I can use something called a Runnable config. We'll see what that looks like in a little bit. But for now, we've got these tools here, and the idea is I want to go ahead and jump into AI. I'm going to call it tools.py here, and we're going to go ahead and do from LangChain_core.tools. We're going to import the tool decorator. So now what we want is define a few tool functions. So we'll go ahead and do tool here, and I'm going to define a function called something like send me email. And I'm going to go ahead and do subject str, content str. And so the idea here is we want to have some sort of doc string in here. This is required for tools. This doc string would be like send an email to myself with a subject and content. And then we would have some arguments in here that are related to that. So basically you just want to give some sort of prompting for what this tool is for. It doesn't have to be too robust of prompting. This I think is fine. So next what we would want to do is put a try block in here. And what do we want to do? We want to send an email with the subject being the subject and then the content being the content. And of course that send email is from my emailer under sender, right? So there we go. We got subject and content. Great. So let's go ahead and bring that one in. We'll just go ahead and do from api.myemailer.sender. We'll import send email. And then the reason I'm doing an exception is so that when I call this tool through my LLM, or in other words, when the LLM calls this tool, we'll go ahead and return back just something like not sent, or return back something like sent. And this should be send email. I think that's what we called it. Nope, we called it send mail. Okay, let's make sure we have both of those correct. Great, so there we go. We now have a tool called send me email. So we could take this same concept and do something along the lines of our tool for define get unread emails. And we'll go ahead and do hours ago as argument. And in this case, I'll go ahead and do something like 5 hours, right? Let's go ahead and jump into our inbox itself and see if there's things that have happened within the last 5 hours. So there are kind of things that have happened. So I'm going to go ahead and actually change it. It makes it a little bit wider of a scope. And we'll go ahead and do 48 hours to start. And so once again, you'll probably want to have some sort of doc string here. I'm just going to go ahead and copy and paste one. But basically read all my emails within the last n hours. And then there we go. And then we want to return a string of emails separated by a line. So what this means then is our inbox reader, remember it sends back emails. We're basically going to be doing this right here as a response. I'm not going to actually modify this read inbox right here. Instead, I'll have the tool do it. So this is one of those examples where if you're using some sort of API service, you may or may not want to change the way you call that API service, especially if there's other logic in your Python project that's using that and breaking it down in some other way. In this case, we're really just using this, email fetcher thing in here. So we're going to go ahead and bring this read inbox into our tools here. And I'll go ahead and bring it with from api.myemailer.inboxReader, import that read inbox. Okay, so then of course down here, we'll go ahead and do emails equals to read inbox. And then it's going to be hours ago. And then we'll make sure verbose is false. We don't need those print statements coming through at all on the tool. Okay, so with this, I want to go ahead and clean out this data. So go ahead and say cleaned equals to an empty list. And then we'll go ahead and do for email and emails. Naturally, if you wanted to see exactly what's coming back from that email, you would just print it out. And, once again, we might also want to have a try block in here for the API lookup and just basically put an exception in here, a catch-all saying something like error getting latest emails. And then, of course, we'd probably want to log it and do all that to see exactly what's going on with this inbox itself. So now that we're going through all of these emails, all I'm going to do here is I'm going to grab the data. I'm going to go ahead and do something like email.copy. And then basically I want to see if HTML body is in this data. Then I'll go ahead and just pop it out or remove it basically like that, because I don't really want the HTML content kind of muddying this up. The AI, the LLM, might be able to parse what's inside of HTML content, but it also might not be able to. So we kind of want to avoid that. Now, when it comes to getting unread emails, maybe we don't even want the content itself, like what's inside of there. But I will actually bring it in. So what I want to do here now is bring out a message. We're going to format a message very similar to that print statement where we'll go through for key value in the data.items. We're going to go through each one of those data items and we're going to make a new message here that will then go ahead and do plus equals to some sort of string substitution, which will be the key and then the value. So basically just turning it into a string. And then finally, we are going to go ahead and do cleaned.append that message. There we go, for each email message. And then the final one, we're going to go ahead and return back a new line with some lines in here, dot join of those messages, or rather of those cleaned messages. So it's just a string that comes back. So we'll go ahead and return this as a string. And this is also a string that comes back. LLMs are really good at reading strings. You know, they could probably read a Boolean value as well. But the idea here is we probably don't want to give it dictionary values or lists. Modern LLMs will probably be able to do that just fine, right? So the more and more LLMs get more robust, we probably could just send back the emails directly and it'll know what to do. Like the latest OpenAI or Anthropic stuff can probably do that. You would just maybe need to send it as a string or something like that. But our open source one, through my testing, didn't work so much. But here's a couple of tools that I now want to be able to call. Now, we can actually do this with just our simple OpenAI LLM that's actually using our actual LangChain and also our model in Docker Runner. So we can use that one as well because it has tool calling. But of course, we need to wrap in some sort of function to be able to do that. Let's take a look at how that's done. So now that we have a couple tools, let's go ahead and create an email assistant. For this one, I'm going to go ahead and open up in AI. I'll go ahead and do assistance.py, and then we'll go ahead and define email assistant in here. And this is going to just take in a query with a string, and then it will turn something. So this is actually going to be very similar to our generate email message, functionality or service that we had before. So I'll go ahead and copy some of that in here and just replace a few things in here as well. And so there we go. Okay, but this time we're not going to actually do a structured output. While you could have a structured output, we really just want to have a simple message coming back from the LLM based off of our tools. So at this point, I'm going to go ahead and do from api.ai.tools, we're going to go ahead and import our two tools in there. So that was the send me email tool and also the get read email tools, like that. So what I want then is my email tools, and I'm going to go ahead and actually quite literally use the same name of the function here, like this. You'll see why in a moment, but the idea then is we come in and now we have a couple tools. So within just LangChain, we can actually use our LLM still. So once again, it's the chat OpenAI LLM from LangChain. We come in here, we can actually still use that LLM base, but this time instead of a structured output here, we're going to use something a little bit different, which is LLM, and this is LM_base dot bind tools. So in here, we can bind specific tools. So I could actually make a list and bind them just like this. This is just so that our LLM knows about these tools. If you remember back to using Docker Hub, so if we go to hub.docker.com and we go into our AI models, it's really important that whatever AI model you get actually has tool calling in there. So if I look for one that may not have tool calling like this right here, this functionality will not work, right? So whatever model you end up using, you need to have tool calling as a functionality in it. Otherwise, it will just simply fail. Okay, so now we can have these messages again. This time I'm going to go ahead and just make them a little bit more simple. I'm just going to copy and paste a prompt here. You are a helpful assistant for managing my email inbox. That's it. And those are the actual tools in here. So on one hand, I could hard code the tools like this, or I could use something related to this one, which would be using the LLM again, and then binding the tools based off of the list of those keys. So I'll just go and say list.keys here, just like that. So same tools, just defined slightly differently. Every once in a while, I'll even have just a list, something like email tools list, and I might even write those tools directly, or I'll do that same sort of idea. So a lot of different ways on how you could actually define those things, as many things are. So what we've got here is now our email assistant, right? So I'm going to go ahead and do my response here, and then I'm just going to go ahead and return back that response. What's going to happen with this one? So at this point, I'm going to go ahead and save it, and I actually want to build my container so we can take a look at this. So let's go ahead and do our Docker compose down, and then we'll go ahead and remove orphans. Okay, and then I'll go ahead and build it back up with watch and build, and then that shouldn't take too long. Then I'll go ahead and do Docker compose run, and of course it's our backend and bin/bash. Great. So now we're in here. I'm going to go ahead and run Python directly in here. Then I'm going to go ahead and do from api.ai.assistance import everything. Okay, so if we get any error like this, like no module name Gmail IMAP parser, this has to do with the relative import of this Gmail IMAP parser inside of the inbox reader. You may have caught this on your own, but if you didn't, here we go. I just caught it with that error. So we just want to have that absolute import there for my emailer to make sure that that part's working. Okay, so I think that saving it might have solved that problem. Let's just check. Looks like it did. Great. So that's one of the advantages of doing that binding that we did before to the volume, right? Yet another one. Okay, so the idea now, of course, is we're back in these assistants, and so I should be able to go ahead and give a query. So something like, show me my latest email, right? And what we get here is some sort of function validation issue that's coming back in here from this one. The obvious problem is fairly obvious. This should be values, not keys. Oopsies. Okay, nice little error. Let's try that again, and let's try this again. Oops, and we will import it, and then we'll run it. Okay, so what we'll get back is some sort of response here. Now, the response is maybe not what you expected. So if you're using LangChain, this might be like, oh, what's going on here? If you were using LangGraph, you'd probably see something a little bit different than this, as we'll see very soon. So LangChain just tells you, hey, here's the AI message. Now you can write out the code to actually call out that message. LangGraph shortcuts this, as we'll see, but the idea is inside of this response, we need to actually handle the tools themselves. So what I can do here is let's go ahead and grab that response, and we'll call it once again. And we can see response.toolCalls. We hit enter, we see that it's a list. So notice that it says name get email unread emails. The reason I have this key here is because now what I can do is I can say the tool call equals to this response of tool calls at the 0th element. Granted, there are more than just one, but here's the tool call now. And of course, if I do .get and simply name, I get the tool that I want to use. In other words, I could go ahead and do email tools of that value, and I should get the actual function itself. And there we go. So now we have a function, a structured tool in here that I can now call. So the idea then is down in our response here, we would say something along the lines of if has attribute the response itself of tool calls and response.tool calls. Then we'll go ahead and iterate through the tool calls because it might do more than one. I haven't seen it do more than one in my own tests, at least on this model, but it could do more than one, in which case we'd want to loop through all of them. And we'll talk about how we handle that in just a moment. But the idea here is our tool call, we want to grab that tool name. So very similar to what I did right here, I want to go ahead and say tool name equals to tool call.get of that name. And now the tool function, the actual one I want to invoke, is going to go ahead and go from this email tools.get of that tool name. So this should be one of those functions. Granted, you could have your own sort of control flow, like a condition here, saying if name do this, if name do that, but I want to just do it like this. It makes things a little bit easier to me. And then I'll go ahead and say if not tool function, if there is not one already mapped, I'll just go ahead and continue through. So if for some reason it's trying to call a tool that I don't have in this mapping, it's just going to skip it. That's pretty much the idea. So one of the things I didn't really show you with these tool calls here was the proper way to use them. So before I go much further, let's go ahead and actually use a tool here. And the way I'm going to do that, I think I already have one of these tools available. Let's see. And we do. So the way we can do this is by calling .invoke. And in the case of leaving out parameters, we can just use some sort of empty value as a dictionary. It has to be an empty dictionary when we call .invoke on a tool. And there we go. We get some of that data back. And then we can also try this out with send me email.invoke. And then we pass in the arguments that are there. So subject being, is this working? And then I think the other one was content. And we'll go ahead and say, yes, it is, right? And of course, if everything's mapped correctly, then this will actually send an email, in which case I can look into my inbox and we see, is this working? Fantastic. Okay, so we now see how to actually invoke any one of these tools. So in other words, we've got this function here. We can go ahead and call toolfunct.invoke. And then of course, the question then would be, what do we invoke? Let me scroll back up a little bit to where we actually called that tool and we saw some of them in there. And we see the tool call is right here. We also have an argument for args, ID, and type. Okay, so I can actually call this based off of that. So inside of here, my tool, I can now also say tool args equals to tool call.get args. Once again, this is that tool call right there. We've got args. Here are those arguments in here. And this is exactly what I can invoke for that response. So then finally, we would have our tool, let's say result equals here, that actual result. And then what we can do from that result, we can do messages.append. And that's quite literally this message right here. The result that will come back will be able to be appended to that result. And then after all the tool calls are done, we'll go ahead and say our final response equals to llm.invoke. And then that would actually invoke the current messages like that. And then we can return back that final response. And there we go. So this step is something that just has to happen if you want to be able to call those tools within line of your quote unquote email assistant. So with this in mind, I'm going to go ahead and exit out of here. We'll go ahead and go back in because I saved some changes, and I'm just going to go ahead and import everything from the assistant. And then I'll go ahead and say something along the lines of send me an email about needing more coffee. There we go. And so now I'm just telling the assistant something very basic or seemingly very basic. We get back an error. It's a 500 message saying conversation roles must alternate user, assistant. The problem here is the actual message response itself also needs to be appended. So basically I got a response back. I need to append it to my messages. So we'll go ahead and do .append of the response itself to make sure that it is alternating the way it's supposed to. And so this right here is also going to be appended. So whenever you invoke basically a tool and you want it part of the messages, you want to make sure you append that as well. Another thing that LangGraph does super well. So now if I were to send this again, I should get some sort of fairly good response in terms of the tool itself. If I save everything, I got to exit out and try it again. So let's go ahead and do that. And then we'll go ahead and send me an email about needing more coffee. And there it goes. So this is a proper response, and we see the AI message is coming back in there and all that. So if we actually look in our inbox, I did test this a few times, but here's those emails coming through. And it's funny that they're all basically saying the exact same thing. They didn't change at all. Naturally, we could change it in some form or fashion. Let's go ahead and say something like, send me an email about needing to meet with Jon Snow later next week, right? So another way to do some sort of email assistant. And there we go. And there it is. Now that we've built out our email assistant, let's see LangGraph in action. I think it's pretty great, and hopefully you will as well. So the idea here is we're going to jump in to our project. We'll go into requirements, and we want to make sure that LangGraph is added in here. And then in which case I'll have to bring down my backend and bring it back up with it being built. Okay, great. So with this in mind, we'll go ahead and now create our agent. Notice that there's this pre-built section for agents to actually work. So it's actually fairly straightforward. I'm going to jump back into Cursor here. under AI, I'll go ahead and create agents.py, and then we'll go ahead and copy their example for right now. So the idea, of course, is we already have some tools, so we won't need those tools. We will use an agent with our own model and our own tools and all that. So I'm going to actually make it very similar to this one, where it's going to be sort of our email assistant agent. So in this case, I'm actually going to define it as get email assistant, and then we will go through the process of generating out the email assistant directly, similar to what we've seen in before. Okay, so I'm just going to go ahead and eventually return back the agent with the various tools. I'll get rid of the examples that I had here because we no longer need those. The model, it does shortcut the model if you want it to, or you can use the LLM that we created directly, which is what we will do. So we're going to go ahead and do from AI or API.ai.LLMs. We're going to import our get OpenAI LLM. So our model is going to be the OpenAI LLM. At this point, we don't need to bind anything. We can just go ahead and do that. That's all we really need to do here. Then, of course, our tools that we want to have, which is going to be similar to what we did with our assistants as well. So I'll just go ahead and copy those things out. So in this case, I actually probably don't ever need to use this email mapping like this. So this is where I would do something more like a list itself, which I mentioned before, but we'll go ahead and do it again and make sure we do .values. And so this is going to be now our tools that we're going to add in. There's a possibility that we'll add more tools here. So I probably actually want to leave this a little bit more vague than that, as in not based off of some sort of, dictionary value itself, but rather give it explicit values in here because we'll probably change some stuff, as we'll see. Okay, next up, the prompt itself. I'm going to go ahead and just copy the same sort of prompt that we did for the other one that we did here. These prompts can absolutely be improved in the long run. Okay, so this is going to be now getting our email agent, not our assistant. You are a helpful assistant for managing my email inbox, for generating, sending, and reviewing emails. Something like that. Now, it's not going to build drafts or anything like that. I mentioned that before, but that's kind of the idea here. Okay, so now we've got our get email agent. Let's go ahead and open up the shell so we can see this in action. So we'll go ahead and do our docker compose run backend bin bash. Then we'll go ahead and do from api.ai.agents. We're going to import all. Oops, I didn't go into Python, so let's try that again. And we'll copy this. Great. So let's go ahead and get our agent here, and we'll go ahead and get our email agent. And now I'll do agent.invoke, and we want to put in message. That is the format that has to be called, or rather messages. And then you'll go ahead and say something like, what are my recent emails? Assuming that that is still configured correctly, we can just go ahead and invoke it. And now, if it's correct, it will actually send back some sort of response for us. Of course, it's still using our local LLM, so the speed as to which this will work is going to vary. But the idea here is I get a little bit of an error. Looks like maybe something's wrong with our tool. So let's see what we've got here. Inside of our tool, error getting latest emails, and the request exceeds the content size. Oh, that's the problem there. So I'm going to go ahead and return back up to like maybe, 500 for now. I'm not sure if that will make that much of a difference, but let's go ahead and save it. And let's go ahead and try that again, because naturally we had just way too many emails coming back for the content size of this particular AI model. So let's see if this ends up doing it. What are my recent emails? There we go. So we get a response back, and we can actually see in our messages in here, here's some of our messages, right? And it's actually going through, okay, I've received it. It's from GitHub, regarding a third-party application, and then, DigitalOcean, and so on and so forth, right? So we've got other things in here. So maybe it's not necessarily needing to get all of our recent emails. Maybe we want to limit them, the number that are coming back, or maybe we just need to use a more powerful LLM to be able to handle bigger context size. So next up, I'll go ahead and say something along the lines of, send me an email about coffee, right? And so once again, it should actually invoke that. And there we go, coffee thoughts, and that's it. So we now see how much faster it is to build out this tool calling agent. This is a very simple one, and we could make it more complex. But the nice thing about this is I now have an email agent that I can wrap into any other agents. So I have covered this in another video that's related to Django and handling these agents, but you can also just look in the LangGraph docs. I think the LangGraph docs are far superior to the LangChain docs because there's just so much more thing in here. So if you go into multi-agent as well, you can see that there's something called a supervisor. So now we have a new assistant or agent in here that we can wrap into a supervisor that can help us build out some other stuff. I will show you how this is done in just a moment, but overall what we've got here is a very powerful way as to how we can say, hey, send and look at some recent emails for our agents. And it's really just these few lines. It's pretty great. We're now going to add another agent, mostly for research purposes. So what I'm going to do here is I'm going to go ahead and copy the email agent, and we'll just call this our research agent. And so what we will want to do is we want to build on top of this. And so I'll basically just give an example here. I've got my research agent, and I want to create a tool called research email. We'll look at that tool in just a second. But the idea here is we've got you are a helpful research agent for preparing email data. So realistically, I'm kind of thinking of these two things as different, right? The email agent is for sending email and maybe looking at email. The research agent is just simply for research. This is where our OpenAI LLM, the actual model we use, even if it's an open source one, we might want to make it more robust for the research agent and less robust for the email agent since it's fairly simplistic as to what it's doing. But in this case, I'm just going to use the same exact model, and then we'll wrap these things in with something called a supervisor agent really soon. So let's go ahead and create the research tool. Now, if we actually look back to services, we kind of have a research tool already. You are a helpful assistant for researching and composing plain text emails. Great. So I already have this tool, and it has some structured output. Now, this is not quite a tool yet. So I actually want to turn it into a tool by actually coming into my tools here. And now I'll go ahead and create a new tool. And this one I'm going to define as my research email tool. And it's going to take a query, and then it's going to do some stuff. So I actually already thought this out and tested it a little bit. So I'm just going to go ahead and put these things in here. You could do this as well, but basically this right here, that's pretty much it. Then, of course, we want to bring in the service. So from API.ai.services, we're going to go and import the generate email message. Now, something that's important about this tool at this point is it actually will call an LLM. It'll actually call an LLM for us. So this is not fully necessary in terms of using an agent. Like the agent itself doesn't need to call another tool. The agent could actually do the research on its own. But what I'm doing here is I'm showing you that you can absolutely start using other AI models inside of your tools. So it's really just to give you that practical experience of like, oh, well, what if you wanted to have, whether it's a more robust model or if you wanted to use an API service or whatever, right? So this tool can do all of those things, and then it'll return back this string in here so that then my agent will be able to use that stuff. So with this in mind, I'll go ahead and now import that research email tool. And so now we've got a research agent. So at this point, you could obviously test these things out, but really it's like, well, where do I go from here? And that is using these two agents in tandem with something called a supervisor. We're now going to create a multi-agent system that is managed through a LangGraph supervisor. This is because we now have two agents and we want to be able to move things back and forth. Now, doing supervisor agents probably means you're not going to be using the open source models just yet, the open source AI models. So from my testing, none of these open source AI models really worked well with the supervisor. They work great on the individual agents, but when it comes to moving things back and forth, they kind of fall apart. So for that reason, I actually went ahead and grabbed some API stuff inside of OpenAI, and that's what I'm actually going to use locally as well as in production. So that is where we're at right now. So in my env here, I'm going to go ahead and comment out some of these things. The model name, I'll go ahead and use it as GPT-4o. You could obviously use a different one if you'd like. And then I need to use an actual API key here, in which case I'll go ahead and copy that one and save that in. Great. So with this in mind, I also need to do one more thing, which is going into my requirements here. I need to bring in LangGraph-Supervisor. We'll go ahead and save that. And I'm going to go ahead and run my Docker Compose down and remove my orphans here. And then we'll go ahead and bring it back up with that build call like we've been seeing multiple times. So while that's building, I might have to rebuild something soon too, but inside of my agents here, I'm going to go ahead and import my supervisor. So we'll go ahead and go right underneath from LangGraph_supervisor. We're going to import the create supervisor here, and then we'll go ahead and start this process. In this case, I'm going to create my own function, and we're going to call this get supervisor. And we want to actually declare several things here. First off, what model do we want for our supervisor? This is not for our agent. Each agent can have its own model. That's totally fine. And even in that agent, we can see that some of the tools have their own models as well. So you can have models on models on models. Do keep in mind that the more models you have, the likely that your costs go up quite a bit. So do keep that in mind when you create these multiple agents and all that. It starts to really get expensive, I'd say. Okay, so what I'm going to do here is I'm going to get the OpenAI LLM model. Once again, you can declare whatever model you want in here on how you're going to go about approaching that. Then I'm going to go ahead and do something very similar to the agent here, but this one is going to be create supervisor, this function call right here. And so we've got our soup, which I'll call just simply soup, and it's create supervisor, and it's going to take in agents as a list now. And then we're also going to go ahead and add in our model here, which is going to be LLM. And then I'll just go ahead and give you the prompt I'm going to be using here, which is just really you manage a research agent and a email inbox manager assistant. Assign work to them. That's it. And then finally, at the end of this, you do .compile, and then you're going to go ahead and return that. Okay, so what are the agents that I'm going to be using? Of course, my research agent and my email agent, which have their own tools. So my supervisor does not need to define tools at all. So I'll go ahead and do my email agent, and we'll go ahead and do get email agent here. And of course, that's going to be one of them. And then we'll do the same thing with our research agent and like that. Now, there's one more aspect that we need to do on our agents now. With this create React agent, we need to give each one of them a name, in which case I'll go ahead and just say name, and this is going to be my email agent, and then a name down here. Oh, it looks like I already have a name down there for research agent, but both of them need a name. Great. So at this point, we now have a supervisor that's ready to go. The supervisor itself, the way we're going to call it is like this. So I'm going to go ahead and put a little comment right above here, but it's supervisor invoke. We add in messages, and then we're going to go ahead and add in a list of items in here for our user and the content in there. Just slightly different than what we've seen before, but basically it's going to be soup equals to the get supervisor like that. And oops, that should be just this right there. So that's what we're going to want to do to see how this supervisor ends up working. So let's go ahead and try this out with going into our project here. We'll go back up into our backend. I'll jump into Python. We'll go ahead and import, or rather from api.ai.agents. We're going to import everything. Hopefully everything works correctly. It looks like maybe we didn't save something in our tools. I don't know if I saved my research email tool, so let's try that again. Now I saved it, great, now it's working. So we'll go ahead and grab our supervisor, and then we'll go ahead and invoke that supervisor like that. And this might take a little bit of time. So find out how to create a latte, then email me the results. That's pretty cool that I would be able to do such of a thing, right? And so the actual results, how it ends up looking, all of that sort of stuff is going to be dependent on a number of factors. One of them being how well the research agent actually does research and the tools available. So in this case, it's actually calling a couple different LLMs, so it will take a little bit of time. There is some latency in here because of how much work it ends up doing, but then it's all done, right? And so you could imagine you might even put this in as a text, chain. You could start texting an agent and say, hey, email me this information, and there we go. So here's some cool stuff. I think it looks pretty good. And of course, you could always try other things in there as well. The key to me is how simple this stuff is to get going. Now, you could make these a lot more complex. LangChain and LangGraph both have a lot more complexity that we can start unpacking in here. But the thing is, a lot of the models themselves are starting to do a lot of the work. The tools that we build are what really help us do very specific API lookups or AI lookups. We can do all sorts of things in our tools. The agents are just getting so good that we really don't need to do that much with them because of how good they're getting. The other part about this is I like to think of each individual agent as something that does one thing pretty well or one thing really well. It doesn't try to do too many things. So as soon as I'm like, oh, I need some more tools, I'm going to go ahead and probably build out a new agent. So I think in the near future, we're going to see a lot of different agents happening. And I also wouldn't be surprised if there's a way to do supervisors with supervisors where they kind of communicate with each other that then have their own agents and stuff like that. That's probably going to happen if it doesn't already happen. I just haven't seen that just yet. I think Swarm is probably this concept, but overall, we will see a lot of different things happening in terms of how these supervisors end up working. Now, there are more complexities that we can do already, something called a handoff, where it can then work within the agents and all that. But that's outside of the scope of this one. I really just wanted to show you all of this so you have a better sense as to why you would want to use LangGraph in the first place. Let's take a look at why the LangChain tools are so important, and it has to do with the runnable configuration. So what we're going to do here is from LangChain _core in .runnables, we're going to import the runnable config. And what we do in any given tool here, we're going to go ahead and add in config is this runnable config. So the way we name this is, I think, up to us. So we could probably call it ABC config as well. It's really just the type of config. And so all I really want to see here is what this is going to look like. So I'm actually going to go ahead and use it in a very simple way where we're going to go ahead and print out the config here, just like that. And so I'll call this agent, this Git research agent for this runnable config so you can see how it's done. Now, I'm not going to use it in this project because I won't need to, but we do want to see why those tools are so important. So let's go ahead and do docker compose run backend, and I'll just go ahead and call Python directly, make it a little bit easier. So we'll go ahead and do from api.ai.agents. We're going to import all, and then I'm going to go ahead and call my research agent. Okay, so agent equals to research agent. So normally when you want to just call it, you would just call something like invoke and, perhaps your message or messages and say something like, what is the best way to prepare chicken or something? I don't know. Just come up with something. You run that and they'll invoke that message and all that, right? So it's going to go ahead and run some stuff and probably call even some of your functions, and then we'll get something back. Okay. So the nice thing about this is when I printed out the print statement, so all of this right here is the runnable configuration. So that's what we're seeing right away. It didn't finish our message. We just saw the runnable configuration. And so in which case you would be able to change these things as you see fit. So in the documentation, it shows you all sorts of stuff that you could do with this runnable configuration. So for example, you want to invoke it with an additional field, whether it's your user data or something along those lines. You could then use that same config here and you just pass in the config at configurable, you run that, and then on your actual tool itself, you'll be able to see that data coming in here. In metadata, you see additional field here. There it is, 1, 2, 3. And then also in configurable, it's also in there. In other words, in the research email itself, we can go ahead and say metadata equals to config.get meta. I think the metadata version is newer, where configurable has been around a little bit longer. But I'll go ahead and grab that metadata argument here. And then from there, I'll go ahead and say my additional field is equal to the metadata.get of that additional field. And then we'll go ahead and print out what that is. Right? And so I'll comment this out and we'll go ahead and say something like add field, obviously additional field. So I'll go ahead and exit out of my shell here just so that I can run this again. And then I'll go ahead and do from api.ai.agents. We're going to import all, and then we'll go ahead and run our call again which of course is going to be our agent. This is why I usually use bin/bash and not Python directly. Agent.invoke. And here we go. We got our message and say, what is water? And then there we go. And then we'll do our config, which I will just grab from the docs again. Feel free to do this as you see fit, but it's just going to be one more moment. And there we go. So I went and printed that out and notice that I've got this additional field in here now at the tool level. The reason this is very, very useful is for users or sessions or both, right? Or organizations or any other sort of data you might need to enrich in this request. That's not going to come from the query because you would not be passing that query in. In other words, your user is not going to be like, hey, I am user ID of 123. Make sure you include this in my request. It's never going to do that. Or I work for this company. Make sure you include that in my request. Now, they certainly might do those things, but for sure, when you need to do those things, that's when this runnable config is really important. And you get that by default when you use the tool decorator inside of LangChain itself, which I think is pretty great. So I'm actually going to comment these things out. I'm probably never going to use them in this particular project, but it is important to know because at any time when you need to use them, you totally can. It's now time to update our API endpoint in our chat to use our supervisor now. So the process is going to start with the schema response, actually. So we're going to come in here into our schemas, and I'll just go ahead and do class supervisor message schema. And it's going to be a base model. And all it's going to be is content. That's all we want to return back. Okay, so we'll bring this into routing instead of the email message one, which I'll keep both of them in there. I'm not sure if I will need both of them, but I'll go ahead and leave that in there. Next up, we'll go ahead and bring in our from API.ai.agents. We're going to import our Git supervisor here. And then inside of my message, instead of this response, I'll actually put the supervisor in here. So let's go ahead and get rid of these comments. And we'll go ahead and do our soup equals to Git supervisor. And then the actual messages, as you may recall, was basically like this. So we'll go ahead and say our MSG data equals to the messages. And that is going to be a list of items in here that we add in. First off, the role of user. And then inside of that role of user, we're going to go ahead and add in our content here. And this would then be our message that we had prior. So if we look in the chat message into those models, we see that there's a message there. So realistically, it's going to be the payload.message. I think it's either one. So both of those are the same. So this is going to be in here. We'll just go ahead and use payload.message. Okay, so that's what's going to be coming through here in terms of our message. Obviously, if it's empty, it would have some issues that we would want to have some sort of fallback in there. But there's our message data. So now we'll go ahead and do our result equals to soup.invoke that message data. Then we'll go ahead and actually get that result. Realistically, we'll say something like, if not result, then we would probably want to raise an HTTP exception, in which case we'd want to bring this in from a FastAPI. So let's go ahead and do that. And the exception itself would be like status code of 400 and detail. We'll just leave it in as error with supervisor or something like that. After we get that result, what we get from the result is something for messages. So result.get messages. And then if not messages, we'll do that same sort of error here. And then finally, we'll get the actual message itself, which will be the first one. So we can always print out what the last message was or the most recent message was, or we could just return it back from messages itself. Because of our schema, it should actually give us content back based off of that. Great, so it's going to be really just that simple. So all we would need to do is update a curl call to it, which I'm going to go ahead and put another one right here, which now has research why it's good to go outside and email me the results. Basically leveraging everything we can do inside of our research agent. So I might need to bring everything down and bring it back up. I'm pretty sure I won't need to, but I'm going to go ahead and do it anyway. Should happen really fast if I don't need to. Now I'll go back into my terminal and I'll paste out this curl message. Again, very similar to what we've seen before. I run that. This will take some time, but hopefully what ends up happening is we will see in our inbox really soon as to that message. Now, the latency, again, a lot of different reasons as to why this could take a while to actually run, and there's probably a bunch of improvements we can work on to make it work even better, but it's calling LLMs many times to get this result and to make sure that it's all working really well. So at this point, we might think, oh, well, maybe we only kind of do our research agent to being a little bit differently, right? So in our research agent, we've got this tool here that also calls an LLM. I might not necessarily need to do that. This might be better if I actually have an API call than just calling another LLM, because it ends up slowing things down a bit. But there we go. It did a response. Here's that content coming back. So the schema ended up working. And then if we look at our email, there's our email of that. And we obviously could try it again with something different, like research best coffee or something like that with our curl call. But that's it. We now have an AI agent, a multi-agent supervisor at a FastAPI endpoint. Of course, this is fairly straightforward. The things that we could do to improve it are adding memory, so we can have multiple chats with this user or adding thread IDs and all that. I'm not going to do that at this point, but you definitely could. There's a lot to it to make it work really well in production. This right here should work in production as is. As a final step, let's go ahead and deploy this. We shouldn't have to change anything. It should just work. So all I'm going to do here is do git status. Let's just make sure that everything's added. I have been doing git commits this whole time. I'm going to go ahead and say something like, now using new API and agent, something like that. And then git push alt main. In my case, it's alt. You would probably do, origin. But there it goes. It's going to now kick off a new one. Now, in my case, I actually just exposed an API key because of where I put it. So inside of env.sample, this is an exposed API key. So is this. Both things I do not want to have anymore. So I'm going to go ahead and jump in here and I'm going to get rid of them in my project. I'm also going to revoke it on my Google. In addition to revoking a few API keys, I jumped into DigitalOcean where I have it deployed into my settings for my component. And I went ahead and added a bunch of different environment variables to ensure that that stuff's all going to work as well. So definitely my email stuff I had to add. I don't think I did that on the video ever. So I went and added that one. I also added the OpenAI key and all of that. So all of this should be now ready to go in terms of just getting this whole project working. I'm just going to let this finish deploying so that we can then verify our final project and seeing if the supervisor ends up working itself. While that's running, I will actually give it a try here with the API endpoints that I have and basically the same sort of message on my project. So I'm going to curl it here and I'll go ahead and give this a run. I'm not positive if it will actually end up doing the email part or the supervisor part, but it is going a little bit slow. So I'm feeling fairly confident that it may have finished actually deploying all of those changes because that latency is kind of a given based off of all the things it's going to research and do. And so hopefully what we'll end up seeing here beyond the security alert will be that actual message that it's generating. Okay, so I had an issue with some API keys. I went ahead and solved those, but now we see that my production version can absolutely send me stuff, or at least it says it sends me stuff. So I'm gonna go back into my inbox. There it is, best type of the food around the world. Pretty interesting. I'm pretty sure some of these things look really interesting and I'm sure they're great. But overall, the idea here is it's now in production. We can now use it in any of our apps. The thing that we need to be aware of is it takes some time. The latency is there. It's not meant to replace something like ChatGPT at all, but it's really meant to help us do research. So what we could do here going forward is we could just have this run on a schedule. So let's say, for instance, if you went into GitHub, what you could do on GitHub right now is you could actually build out in your repo, any repo, you could build out a GitHub action that runs on a regular basis, and that can actually call this API endpoint, which would then give you the results that you're looking for in your inbox, maybe on a daily basis, maybe every few hours. All you would really need to do is call this API endpoint itself. Hey, thanks so much for watching. Hopefully you got a lot out of this. Now, be sure to delete all of those API keys that you created and any resources that you've deployed that you don't have any intention to use going forward. Otherwise, those bills will rack up. Now, I will say there is another challenge you're going to want to undertake, and that is adding a thread ID and some memory to your supervisor agent. Spoiler alert, it's already in the code that has been pushed to GitHub. But the idea, of course, is you want to start adding in new LangGraph features so that your software works a little bit better and you can have better chats with it. Of course, you could also look into doing streaming with LangGraph because you definitely can, and you can also implement it with FastAPI. The last final challenge I would leave you with is doing that GitHub action where it's going to call this on a daily basis to help you achieve some sort of result and have it go right into your inbox. Hey, maybe it's doing a search like, what are today's latest podcast episodes? Something like that, where maybe then it summarizes some of them. Yeah, that might be a really good challenge. And now you have some of the fundamentals to make all of this happen. So thanks again to Docker for sponsoring this one. I really enjoyed doing it. I think Docker is such a great tool. I use it all the time in all of my projects, as you might be already aware. Now, I do think we are still very early in the AI agent world. So the idea here is to continuously build out your agents and kind of start building out a mental model as to how you want to approach them. To me, it's about a supervisor calling different AI agents. Those agents all call their own tools, and they do so in a very specific way. Thanks again for watching. My name is Justin Mitchell. Look forward to seeing you next time.